Oh, actually, I need to press record very quick to make sure I have something to fall back on when needed to. Here we are. Okay. Let's go. Of course, me and my infinite wisdom decided to not putting everything in order before starting the stream, but no worries about that. Let it just make sure that I have everything here. That one we need to go with. Let's see which one we're gonna look for. Oh, slicer. Yeah. Put that there. Main cell. Yeah, main cell, domain cell. Where's that gun? Oh, some behind. Oh, in behind that somewhere. There we go. Alright. Head that away. Like that. Alright. Where do we even start? Oh yeah. Let's show these off now. In the background of the machine running. Totally not because I forgot to print out some stuff before the stream. Well, not that I forget. I put it on the stream before it. I put it on the print before stream start. I just forgot to do it yesterday, so that I can have something to show today. Anyway. Hey, Jack. Uh-oh. I just realized the mic's over there. Alright. Let's hope you guys can hear me from here. But I'm gonna pull this back. And look what the cat dragged in. These are connectors for hopefully V2. Well, not these. These are something I bought by mistake. This is it. So specifically, it's gonna go like that into one of the panel pieces that I have been designing in the background there. And yeah, it's a swivel, little purple stuff. And of course, we're gonna open that. Yank. Oh, the nut. Yank that out. Like so. That's not that. And in comparison, this is what it looked like before. This is the XLR panel white. This is the XLR panel block that the V1 is using right now. And little size comparison there. Now this is great. Size is definitely the smaller the better actually. So I am happy with this, and in comparison, this is the GX12 4-pin connector, and this is a GX 16 connector. So yeah, that's out. Yeah. So yeah, you can stack these three together, and you can tell that this one that I'm gonna use is actually a lot smaller, so much smaller than the other two, and that's great. Oh hey. Hey Justin. Is that the CAN bus USB string leaf? No, this is the connector itself. This is the thing that's gonna be you see that the machine is running, so I cannot yank it out right now. But those are the connector at the back there. I can unplug any of these two head, and no, not any. I can unplug these two head and convert this back to a single two head printer within a minute or so with these connector. So that's the idea. Oh, that's the goal, in fact. So you're gonna put this back there, and oh, there we go. Yep. String relief wire, I think I'm gonna cheap out just like I did back with the V1, and that's rather than having a dedicated rubber string relief, because these connectors are so small. Though these the GX12 connector are so small. Rather than having a dedicated rubbery string relief, I'm gonna adopt the same string relief strategy as I did the V1, where I just double up on the steel wire that backed out the umbilical to make a little stiffer section in right off the plug. That way it serve as a string relief effectively. I think that worked well enough, so I'm not gonna change that now. Anyway, where was I? Yes, with this. So now this look about the same as it was before, but in fact I've been at it for a bit. I've been making a bunch of prototypes, so I can show it off here. Let me just grab them. I've been making a bunch of prototypes. Let's put this camera back in a sec. Yep, I've been making a bunch of prototypes. These housing here, and well, some of them are. What's this one? I can't remember how it's anymore. But some of each of them have their own little pros and cons. So for this one, for example, this wall is too thin, and I think one version of this broke off during printing, so I just threw that one away. But that's become quite a big concern. Then then some of them, like this one, this hole for the PTFE to pass through is too close to the connector hole. So so technically it's gonna work fine, but when you're actually trying to put connector in dealing with the PTFE tube is very annoying. Especially when you have to the connector is a screw-on type, not like just plug and play kind of type. So through all of that, I make some changes. I make this thing a little bigger. The hole is a bit further away. And so far so good on that part. Not gonna lie, not much else about to advertise for myself. Let's just put things together now, just in case. So that I don't lose anything. Plug all the pin back on. Okay. All right, let me do that. I did. The background. So, with this, I think I got everything I need to start building the prototype of this piece now. So I don't want to. With this one. There we go. There we go. So that's that. The hub at the back is for PTFE tube to have some room to swivel in and out when it needs to, and that's that. These gonna work. We'll see if they work or not. We'll see. So what's next? Just to remind myself, let's open the rest of the files. I make some change on the end of assembly. And I also, actually this one hasn't changed at all since the last stream about it, which is the two head. No, the dog, I mean, not the two head. Other than the fact that I now move this to the side so that it look better. That's about it in the cat. All that left here is just to print everything out and with the two head at hand. Plug it on the gantry and see how that go. So all of this need to wait until I actually have a machine and then some. So I'm gonna put this file to the side. Oh, actually, we need to chamfer this now. Do I chamfer that now or later? Oh right, no. Yeah, I definitely do need to chamfer though, because one of the things that I done, I had done, and one of some regression throughout that have been going on with the old file is that we are now going to optimize for the mono version. That is to say, everything all this green bit is going to be printed in one assembly. It's gonna be facing with that face lying down like that. Just hide the rest really quick. Yeah, that's gonna print in all in one piece like that, and with the face laying down like that. It ultimately, I guess one of the commenter in the past video actually make a good point, and that is drilling out these holes with a 3mm bit is easier than trying to print this into two pieces and trying to glue this thing on. So yeah, so that's the now that is now the new standard. And of course, to make that a thing, I had to reconfigure all of this file, and in doing so, I remove a bunch of the chamfer. And I don't feel like doing the chamfering today, so I'm not doing that yet. But that's something that need to be done. Maybe final product after a bunch of more changes when needed. We can leave it at that. And of course, I need to hide this. Now, yeah. So for this file, I'm just gonna leave it at that for now. Get rid of it so that I don't touch it. And for this one, yeah, this is something that I actually gonna be backported to V1, which big news about that in a minute when I feel like it, I suppose. And that is now for this one, for this piece, let's start with this piece first. The news here is that I make the build-in support a lot easier to remove. So before this, there were none of these chamfered faces on the edge here, and turns out when you actually have a test print a few days ago in a hot room, and with a heated chamber, like a very hot chamber, the old support actually, the old built-in support actually weld themselves in place, and you literally have to destroy the piece to get them out, which is very annoying. So I updated just for the release version. So that's what happened here. And lastly, well, actually, before we go into this one, we started this one, so that's just that on this. But the one thing that I totally should have mentioned now, bring up now, is a big news. I don't know when to deliver such news, so I'm just gonna do it now. One sec. Man, really shouldn't repair this stuff beforehand, huh? 3 seconds. Printable. Put that one on store. Yeah, there we go. And too busy to be more there, but we can show it off by the other window. I mean, wait on break. Okay, we can show it off with this thing here. Oops, they were small. They are very small. One sec. Put that over there. Drag that over there. Sure. Yep, that. And there we are. I released V1. Yeah, this time it's an actual release now. It's not in beta anymore. It's in the main channel now. So on printable, it's a paid version. But and I noted here very clearly so that nobody had any weird illusion on this. The free version is still completely available via GitHub. The only reason why I put a number down on this version is, honestly, I just need some of that money back, like 1700 for the time machine as it is, and obviously I had to make a lot of prototypes, so there's actually a lot more than that. Don't tell my mom. I know she's sometime on the stream. Oh, my sis. Actually, my sister's worse. If she know that, she's gonna kill me. But anyway, yep. Ozone. It's a release now. I need to make the final video to celebrate everything and all of that. So it's not fully out yet. I'm writing the script for that video, and that's that. The one thing that is unfortunate on this release is wait on. Oh, it's this thing here, Trident support. I had a feeling that's gonna come eventually, but it had to wait until I will build out the Trident support for V1 alongside V2. So that's basically what I'm doing right now with the whole back panels thing. Yeah, with all, with this one, with all of this, basically. this is all Trident support in a nutshell. Anyway, that is it. Not much else. Not a very celebratory person. I personally enjoy the trial and error part of the design and join celebrating the finished result. So let's put that aside now and move on to what? Oh right. Notebook. I need to write this down. So step 1, we got the dock going, right? So that is the thing at the beginning. We fix some of the problem with the end stop. Okay. We have something with the end stop, which was the thing that there's second in there. Anything else we need to work with? Tool change system. Oh wait, no, I fixed that as well. Tap and change. Tap and change also had been updated. All of this, and while we're still 3 weeks away from August. I love myself. Gonna pat myself in the back there. Maybe I can finally get a vacation for once. With the time between then now and my next payslip, so I can afford the Trident. So tap and chain, end stop, dock, back panel. Back panel had been now been updated. Or still waiting to for more prototyping, of course. So there's still need work to be done everywhere, but I'll have to wait until I get the base machine. So the next thing that we're gonna do, as we close this tab now, is the active chamber management temperature management system. Yeah, let's call it that. That it sounds. Wait, how do I save the new file? Save. Yeah, here we go. I will call this. Let me go check the. Let me go check my. Let's see, naming scheme really quick. Yeah. Oh, right. So 15 is 15. This version. This thing should be item 15 and item 15. Active chamber temperature management. ATM. ACTM. Yeah. There we go. So what this do? Right. Okay, I had a video about this. I already had a video about this. You guys want to go and have it, click on it and give it some watch time, help out with the channel. I'm just gonna post the link really quick. Grab the link. Come on, link. With me. Oh my god, content. There we go. Grab that link. Copy link, and I'm gonna post it in the live chat. It's the video. Let's give it a name. Active temperature. Active chamber temperature management system. Yep. I kind of already note everything that need to be noted on the active management system here in that channel, on that video. So if anyone who got a little bit bored with the stream and want to know what exactly I'm doing for this moment, you can go watch that. The GLDR is the SysStat Pacific system on MissChanger V1 is one of the shortest coming of it. The basically I did not thought about it at all, and everything I add to in light of that, and in trying to manage the temperature within the chamber is basically an afterthought, and it's just an add-on rather than something that I purposely did. To do that, a lot of things have happened. So first there is a fan like the Nevermore Micro on the bottom there, blowing the air underneath the bed to send some of the hot air around the system. And up on top, there's this thing here, which is the Nevermore Del Max that meant to house the filter and also push out the hot air downward, down to the back down to the bed. Unfortunately, the Nevermore Max, uh, the Nevermore Max, so a dual purpose because it can either send the hot air back down or it can send the hot air out. And unfortunately, the sending the hot air out bit does not work very well. It's barely working, so it's delayed the heat up time of the air volume in the chamber significantly. So they drag it out from some 10-15 minutes to several hours. But several hours later, my machine is still gonna get up to 60 Celsius inside the chamber, and that the air within it will get to 60 Celsius, and that is simply too hot for anything that require an open air print temp like TPU, POA, PDG. They all fail within that chamber. So in actual fact, that what that mean is I have to. What that mean is I was restricted. I was restricted on what kind of material I can actually combine with each other. Whether it is so ABS and TPU, for example, is one of the specific materials that I wanted to try out and combine, and I couldn't. Well, for the most part, I couldn't because the TPU would get heat creep and just melt within the chamber before it get into the extruder. And it jammed up the extruder, I mean, all the time because under the ABS printing condition. And if ABS was print in TPU condition, it's warped, it failed, and a lot of the part quality is just not good enough on that one. So what I'm going to preach from now on in terms of that active management system so for the management system of V2, what I want to do is I want to add more capability of to move air in general. That is to say, I want a bigger I want more air to be pumped out of the system faster. There's a specific word for that, and I cannot think of it right now. Actually, rather than let's try to show that via this via the thing that I'm looking for on looking at on to do that pumping bit really quick. Let me just grab that part of the item that I've been looking on. I had on Amazon here. Okay, where is my basket? There we go. So we are building it around this fan here. So the fan on the Nevermore Max are 6525. They don't have a specific number for how much air they can hold, they can carry. They don't have a specific number for how much air that those fans can actually push. So it's hard to do any comparison. The reason for that is actually deal with the strout and all that. They don't have a strout. That's why they don't have a specific number. But more so, well, we can try to compare them with one of these. Or maybe no, not that. Okay, never mind. I was just talking to myself there. Anyway, this is what I want to build my new system around. These 97 millimeter blowers. 97 millimeter because that is roughly the distance between the edge of the bed and the wall of the acrylic panel. Basically, that's the room between in that gap. This will serve two things. Obviously, it's gonna use to be pumping air around the system for one, but for two, it will fill up that space on a Trident. So on a Trident, the gantry don't go up and down like a 2.4. So we have that space to do something with for one, and it is in the best interest for a hotter chamber to have that space occupying with something, so that we don't have more the additional air that we need to circulate or manage in the system. whether for cooling or heating. So this fan gonna be used for that. I'm gonna, and yeah, this fan should fit right at the bottom. Hopefully, I need to test that out once again when I do have the thing with me. But regardless, time to design it. For now, let's just yeah, let's just hope that it works and design around that for now. But I hope for now. Let me let me grab this really quick. Move that down. Not like that. Yeah, I'm just managing some of my window here so that thing can be shown. All right, like that. Okay. So if I go there, what do you see? Oh, you see that? Okay, let me grab that window and I'm gonna move it over here, like so. And actually, we can do this. Oop. Make these two side by side, like so. Yeah, it's much more descriptive this way. Okay, so I'm gonna design thing around these numbers here. Yeah, I'm gonna design things around these number here. Once again, and hopefully they fit. Nevertheless, we can always science them back in to fold when if needed. So starting with this big number on the edge here, and that it's 97 plus and minus half millimeter. So I would say I need let's start with from the bottom, right? The base. Let's go with the base. Hey Vinny, good morning from Brazil. Yay! Hi Dukan. Good evening from UK. Let's go. This the base for now. Do we call it the base? One sec. I need to go grab some numbers from the machine really quick. Where is the thing measure? There we go. Alright. Now you can see my arm, because I cannot see myself, but that distance there, let's say I want it to cover 205 millimeter in terms of the width of the base, and for the depth, and 97. I took it back. 97 is huge. Yeah, 97 is huge. Is it gonna fit? Man, if only I don't have a running print right now. I can just go in there and messing up and testing out. But 97 is huge. It may not fit. Okay, I take that back. God damn it. Oh wait, no. We can still make it work. We can make it work. We can just stand it up right. Right? Yeah, we can still stand it up right. Okay, 97 it is, but we need to make it stand it upright so that it can actually fit in that volume. In that case, we need to do it in the as a multiple of this number. Where's a multiple of the thickness then. So yeah, I was thinking of laying this thing flat on the floor and sucking air from the top, up top, and blow it to the side. But as I just tested out with the tape measure, that may not work. And if it doesn't work on a 300 mil printer, it's definitely not gonna work in no. If it does not work in a 350 millimeter Voron, it definitely will not work in a 300 Voron. So I need to rethink that and just design around that. So we're gonna grab the bottom bit now. So instead of laying it flat, I'm gonna lay it on the sides and blow air, still sucking air from the side. When we can always make a funnel to channel the air from the top down to blow it out to the side. So we're gonna grab that 33 by 33 plus and minus 0.5 millimeter there. We're gonna grab that number. and we're going to design around that instead. And of course, now that we put it on put it on the side like that, that 97 becomes the height of the module that we're working with. So I'm gonna open that now. Now blabbering around. Actually, let me before I start working on this, let me grab some water. All right, be hydrated, guys. It's hot days out there. This here in the UK, that is. It's 34 degrees inside. Got it. Oh, it's gonna be a big long day. So let me grab that plane there. One of the things that I want to do, because I don't know how many fan is enough, is to have the option to add more fan if needed. So how am I doing that? So we figure it out. Let's draw this fan first. Yeah, let's make this fan first. So 30. All right, we don't need a extremely accurate description of this. So just grab a box, a box of 97 by 97 by 33 first. Yeah, I just need some space. I just need to see what I'm doing. I need to see what I'm doing. All right, like so. So just grab a box. Oh, actually. Oh. I just actually, before we do that, I will split an edge. Split an edge. That one. Yeah. Like so. Actually, one enough. One is enough. That one. Oh, that length. That length is something. What's that? That length is 5. Well, no. 5.2 millimeter. The gap. So. Oh my. Come on. 5.2 millimeter in space. That cannot be right. That can't be right. Oh no, it's not. Oh, shorter. Oh, it's yeah, that could be. Not gonna lie. Actually, now that we're on Amazon here, let's just search. So the key here is actually where's it gone? First of all, it has to be one of these blower fan, not the normal actual fan. Yeah, right. So because I'm gonna have to put a filter on top of this, so it need to have the static pressure to pull air through the filter. So delta only, but the other number that is matter here is airflow. Yeah, that's the word I was looking for the whole time. Airflow from these delta fan is 29.4 CFM. Right. Obviously stacked up into double that. We can double, and the idea is that I will have the option to double them up if needed. But delta fan, not delta. Nobody called this delta fan for some reason. It's blower. I don't even know if delta is the right word. Blower fan. What's the size I'm looking for? Let me just roughly grab the tape measure and estimate here. I say 60, 80, no, 70 mil. Yeah, let's go for 70 mil. 70 mil in diameter. Oh, Delta is a brand of fan. All right, it's a blower fan that we follow then. We're looking for a... All right, so 70. Let me just say that for now. 75 by 100, that sounds all right. So let me grab. Oh, I like this already. They got actual numbers that can be used. What's the CFM on this? Good thing I haven't bought it. Bought the other one. Much like that. Airflow 9. Why is the number drop so much? Oh wait, no, you guys don't see it. Yeah, you can go. This thing can go over here. Yeah. Let's say airflow is 9.4 CFM. So this one is the move from 97 to 75. Drop the air down to from 29.4 CFM to 9.4 CFM. What is CFM again? I want to know that what the meaning of acronym. CFM. What is CFM? Cubic feet per meter. Cubic feet per minute. Yeah, cubic feet per minute. Yeah. Cubic feet per minute. Yep. So that is right, a substantial drop. So how many of these small ones do I need to stack to be the equivalent of? Oh my god, careful. Open it. Don't do that. How many of these do I need to stack to be equivalent of one of the other one? So one sec, 29.4 divided by 9.4. 9.4. That's 3. So 3 of these equal one of the other one. 3 in the bottom. Wait, we can look at the other in a different way. We can look at it in a different way, the height here, because the other one will allow to deal with the other one with the option of these two. I can have them up sideways, upright, rather than laying flat. I have them upright, and we will then, in which case the height of that stack is gonna be 97 millimeter, because that's the height of the fan at least. For these, they will lay flat on the bottom, and they're gonna stack them on top of each other in stair-step position, so that they can all control air from the top. So that means that these number 75.5 is locked in, but these the number of fan will add will increase the height of the stack. So that is 30 millimeter there, and we need at least three of these fans to be equivalent of one of the other, the bigger fan. So I times 30 times 3, 3.1. That means it's 94, roughly 94 millimeter. So it's roughly 94 millimeter for the stack of these. What about an overcomplicated solution? You could use a small brushless molder, this RC motor, design and print your own impeller housing. Impeller housing is a no. No, the key with that one is I could not know what kind of number are we gonna be using, so it's kind of hard to work around that. 95 mil. Yeah. 95 millimeter. 42 CFM. Where you got that? Yeah, no, so this the whole winding about this 75 mil one is definitely not it's not good enough for what I'm looking for. So I'm going to grab the 95 mil really quick. 95 mil. And also, yes, I'm searching on UK site, so so I may not have the same number as you do, but yeah, Also 95. Yeah, no, 70 mil. What I'm saying. I might have to design. Might have to still have to design around that's 97 one. And oh wait, the reason why I was so keen on the 97 one, because if you guys will have to keep track on what Prusa is doing. Store. I don't know what. Oh, I misspelled store. Do I? No. Prusa shop. Yes. So Prusa also had a filter solution for their Core 1. And they use that one use 120, a single 120 pulling through a HEPA filter. Yeah, there we go. You can't say for sure, but I'm pretty sure there's not gonna be a HEPA filter small enough for this thing. So I assume the fan that they use to pull air through this thing here is 120. And that's why I'm just gonna take one notch down to the next thing up, that is 97, and then I double it up to make up for the loss in CFM airflow. So that's the idea. Yeah, and from what Dukan had been saying in chat as well, I think I need to design around that bigger side, the 97 one or 95, because well, we are seeing a little pattern across the market now. So both the UK and back in Brazil, for example, it seemed like that around that size is where things are. So it's easier to work around that size restriction rather than trying to find some niche fan that can be only found in that one corner of China, and design around that. It will be it will be very difficult for people to acquire those fans instead of one of these that just easily available on Amazon and elsewhere in the world. So yeah, so all right, and that's basically all that. I think that's enough talking. Let's go back to this one now, because that's what it's gonna be designed now. Around. Okay, make sure that this camera does not block anything too much. Yeah, I'm gonna make that small. Screen is very cluttered, but no worries. Oh my god, I can't even access my own file. Let's go small that. Get small. That also small. So dimension that 90. Ooh, 97. There's no way. There's no way that gap is 5.2 millimeter. There's no way that is the true. That is true. I think 90. I think they meant 92. 552. 52. Yeah, I think they meant 52. Amazon listing, man. Never will. All right. So that is a footprint of the fan. I'm gonna extrude it slightly. No, not slightly. 33 millimeter. Okay, close that. Extrude that for 33. Which way are you going? It doesn't matter. 33. I'm gonna delete this in a bit. Anyway, and it doesn't really shown. Okay. So we'll go back to the sketch really quick. I'm gonna. Yeah, I need to model a little bit of I need to see where the airflow came out from. So one sec. Where's it gone? Split edge. Oh, come on, it's a bit bigger. Yeah, there we go. Found it. And another split here. Get rid of that. I can bend. I can bend this one over there like so, just out a little bit. Okay, this can get rid of that, make that 97. And that can go to be 97 what point, no, that's 96.9. Once again, this number does not mean anything. They just representative of the fan for what it is. And therefore it's gonna show, this is just simply for to see where the fan how the fan gonna fit. So it doesn't really matter how things are with these. And I can hide this. You can rename this as fan footprint. Fan footprint. Yeah, we'll figure it out the rest in just a second. So, bring back the XYZ now. So obviously we need a box around this fan. Yeah. And orientation. Oh yeah, and actually, let's make some more sketches here just to see where things are. Because I need an indicator of where the intake is. We have the indicator of the outtake here. We need an indicator of the intake. So, much like before, we don't need it to be that much accurate. Nor do we actually even need it to be resilient to change at all. This is just a representation of things. So I'm just gonna grab that, put a hole there. What's the number again? 59.8. 59.8. Do you give me a location where I can mount the hole? No. Okay, so it's just somewhere around there. 9 dimension 59.8 59.8 59.8. Yep. All right, so we just run there, I suppose, and because I don't know what specific location is it in this system, so I'm just gonna lock it in there. You guess as good as mine. But that's that. I'll make a little hole. Aesthetically pleasing. Up to face. That one minus a millimeter. That's good enough. Okay. Alright, so that's the fan, that's the intake, that's the outtake. Okay. We can hide that. And let's just make an assembly really quick. In that assembly, we shall grab 2 of these fans. 2, okay. So the first one is locked in. Like that, so that I can grab the second one. I can. Am I not selecting it? Hello? Uh-oh. Oh, there we go. So that's the second fan. Right. So to make 2 of these, to have 2 of these in the same, so you guys know the bento box, right? The bento box system. So let me go to there really quick. Oh, not that one. That one. Let's go on printable. Show you all. Oh, I want to keep this one around. So bento box. So there we go. Is that done? That one. Bento box. Yeah, just something like this, right? So this is something I want to do. Not the fan bit. I'm redesigning the fan bit for my own. And also I'm gonna remake the entire thing anyway. But I like this kind of system where things stack on each other, so that we can. So first and foremost, it means that we're gonna use gravity to hold everything in place, so we don't have to go like figure out latches and seal the seals to make to hold things together. So it's all done by gravity, for the most part, and magnets if needed. And 2 is one of the big drawback with the orientation. I have my Stealth Max. It's the fact that I lay it flat and it create bypass point. That's right. Let's put this correctly. So the filter, no, the carbon bed sit on the bottom. No, sit on the side. So the path of least resistance for the air to go through those that cake of carbon is, let's show it on the printer, not there, because I'm sure some people can figure it out, but make it. So the bed of carbon is roughly take up about that much of space here all around the whole yeah, the better shit, it doesn't work, so we can always open it now. So this is the carbon wheel. This is the and the idea with this thing is supposedly that the air got drawn from the bottom of this assembly through this air gap here and towards the center to get sucked down through a HEPA filter, not HEPA filter, a filter, that filter there, before being sent it wherever it's sent, whether it is to the environment or back into the printer. That doesn't work very well because, well, you can see on the edge of these wheel here, how the dust settle. You can tell that the air is not passing this entire cake of carbon filter evenly. It passed through the top gap much more than it passed through the bottom, and that is because the carbon pellet in here are motivated by gravity. It's packed themselves more on the bottom than it is to the top. So the air will go by the path of least resistance, and that is just go through just across the bed of carbon at the top and into the filter. So there was not much filtering happening with this system as it is in this orientation. I think it would have been a different story if it were like mounted on the back as previously intended, but even then, there's some of that kind of thing is still going to happen. Oh no, I'm saying that kind of thing will happen no matter what. But we try to minimize it. So for the original Stealth Max, they mounted on the back or the side, so not on the top like the way that it is. They mounted on the back on the sides that to keep the carbon wheels on a vertical position, to mitigate that problem. So and if I were for this my new one here, I need to keep that in mind as well. We need to design the carbon bit in the middle to not have to not give air a bypass point. Need to get some water. So that is one of the design aspect of this now. And so I'm gonna do the bait. So that's the idea. Oh no, that's one of the things that I want to keep in mind with the bento design that we're gonna follow, because that yeah, because we don't instead. So it's so the air got sucked through the bed of carbon along the direction of what do you call of gravity. So it's not going. There will be no soft spot within the bed of carbon where more air can pass through and bypass it all, and every other point. And to do so if we follow by following the bento box thing there, we're gonna have a fan at the bottom. So these two are representative of the lower fan, and I'm gonna grab this one, spin it around. Ooh my god, like that. Yeah, I think this is gonna be the fan configuration. So because we don't want to draw air directly on to the side from the side, I want a wall around these two fans. So first of all, let me make these two what? Let me make these get rid of that. Okay, there we go. That's the one. All right, then we make these two distant here. Oh my, don't screw with me now. And of course you do that. Okay, grab that one, spin it again, like so. No, oh shoot, damn it. All right, get rid of that. Transform. So I'm gonna spin it. Ooh, what the hell is going on? You guys seeing this? It's not supposed to happen. That one's supposed to lock in place. What the heck? Alright. I'm gonna count that as a free cat bug. So make that 11. Alright, so go back there. And I'm gonna redo the entire assembly. I don't know what's going on, but so better not trying to fix something I don't understand. So I add in the fan again. Okay, one at a time. This time around. Oh my god. Another fan. This one can go to the front. And we'll spin it around. Like so. Save that. Save it. Yep. Okay. Okay, let's make these two parallel. We know for a fact they are not going to touch because we don't just want to mash the intake of two fans together. That doesn't do anything. Like so. And also the parallel joint is one of the least likely to break. Oh god damn it. Where the hell is my fan? Yeah, there we go. Huh? Ah, I swear to god it's gonna crash in a second. Oh, I know it might. There we go. Yeah. Alright. Just a little more. Come on. Okay. These two need to be... Oh. Not selected. First. These two need to be the same height. So that's why the distance between the two surfaces is 0. Like so. Yeah, so now these two are sort of locked with each other, dimensionally wise. So I can move this back and forth and in and out, but not twist them against each relative to each other. Oh my, but that can happen too. What the hell just happened? Oh, why are you jumping? Alright, so yeah, I think the two fans should be orientated something like that to to be able to, so that in other words we can stack them as such. And we need a wall around them and some fun. And also the key, one of the things that we can point out now is the fact that these intakes are offset to each other. One is facing down from the bottom up, and it's face out coming in from the bottom, and the other one coming in from the top. We may be able to use that to our advantage. Oh, actually, another thing that I realized just now is that we need a gap between these two, like that. We need a gap, this gap here, because if we were to make that face and that face stack up. So if I go like let's do that, for example, and if you imagine there's a wall around this, just like keep everything into it, just to enclose this entire thing into a little box, for example, and have box for example. This gonna suck up the air from this port here, which is not good. Either that, or we keep this one in the same orientation as this one, and we just make sure that there's enough gap after that. Yeah, actually that's a better idea. So let me get rid of that. So, and we transform this. Okay, not like that. Cancel. Can we get rid of that? Can I please transform this? Huh. What's your problem, mate? Alright, cancel. It's supposed to lock in place. Whatever. Let's just get rid of that item. Yeah, it's the same bug. I don't know what's going on. So I'm gonna add another fan here. So move it to the front a little bit. Yeah, so I'm gonna stack it back to back. but like that. And as long as I have some room at the front of this to make sure that this fan is fed, these two should not interfere with each other, right? And if anything, the back of this fan now serve as the one of the four walls that need to encapsulate that port. So that's like a double duty up, double up on things. Of course, you need to make sure to know that there are mounting points that need to be accounted for here and here. Are those mounting points interfere would those mounting points interfere with the path of the airflow? And the answer is yes, slightly. We can always angle the fan a bit, I think. So, but not that. Okay. All right, let's go with this one now. Obviously, this is just references. Okay. I don't even need to. Yeah, I don't even need to. What's it called? I don't even need to lock anything in. This is just there to me to toy around with the orientation and such. So I'm gonna put them all into a folder called ref again. Reference with a capital R. For some reason, I feel like it this time. Fan in. And in fact, I'm not even going to. I'm gonna hide that. Yeah, that can be done easy. Okay, so for the actual part that we're designing, we are gonna start with. Let's start with the bottom. Yeah, let's start with the bottom because I feel like that to seem to be the a bit that's gonna be interesting. Let's see. Body. Where the hell did okay? It add the body to the assembly. One sec. No. We don't want that. We don't want that. Come on. Stop. Go into the assembly. There we go. Oh, there we go. Base. Bottom. Bottom of base. Oh, what the heck did I just touch? Oh yeah, I accidentally pressed F1. So my computer just jumped a little bit to send me to the recap help forum. Okay. Good thing nobody see that. Actually, seriously, it's a good thing nobody see what's going on with the web browser. Nothing going on, but you know, we need to be careful. Let's go with the base. Right. So let me see the orientation really quick. Yeah. Oh wow, that's huge. Can we make the bottom first? Yeah, let's make the bottom first. And thankfully we have the fan exactly where we need them to be. You know, the fan orientated where they should be, right there. So I can't interact with this because I'm not pulling in as a binder for this sketch. But we can visually look at it and say, okay, we know roughly where to put everything. Nope, don't put it at the center point. No, don't put it at 0, 0. There we go. This is it. So let's make this 205. Yeah. And height wise, it will make it 70. 80 pushing it. 70, yeah. This is gonna be interesting. Did we construe this correctly? Oh yeah, we did. Yes, we did. Oh, okay. That's gonna be a little challenging. That means no, it's because these fans are 35 mil, 33 mil in depth. You might need to look for some slimmer fan, huh? Let's look up. Let's try that again. Millimeter 35. So trans blower fan, they seem to be on Amazon at least. Oh, GS time. All right, let's go to GS time store really quickly. But what we're seeing here is the fact that they seem to be the fact that the 97 millimeter here, the size of edge of the space take up seem to be the key thing that they want to advertise.
Not sure why. I think it's a more of a play that matter, but yeah, I'm not GS time. I don't know what they're up to. Fan, lower fan, yeah, there we go. Low 1550. Lower axial, yeah, axial fan, that's more of the word, right? That's more the correct word. 32. Definitely not going for this, too small. Oh, what's this? What's this? 12 pin. No, because it draw air from both sides. I wonder if that's gonna change anything in terms of like airflow. 50-20, so it's very substantially thick. Will it give me good number? Come on, where gone? Where's the airflow rating, bro? Ah, there we go. Oh, 4.1 CFM. Never mind. Very small. It's very small. 9733. That's the one we were looking at. A different variation of that. So something near 97, but lower than 33. Maybe even smaller than that. We got something bigger in here. We got bigger, and they got slightly smaller. Slightly smaller. But still 30 though. 12. Oh wait, hello. 75, 50. 30 mil, 75, 30, 75. This one is 75. Yeah, 75 by 30. 75 by 30. And the airflow, this is 12.7. 12.7. All right, actually, let's grab a reference number, a better net reference number than the 97 thingy. So this supposedly is roughly the same fan that Prusa used for their small core one. Obviously, that one is much more smaller printer than what we have, so we definitely do think something better than this, or combination of fan that make it slightly better. But this one, 20.9, which is smaller than the which is lower than the 97 fan. All right, let's grab the let me grab that one. Yeah, see what this one came out to be. I mean, can we just stack one of these into the system and just call it? Where are the numbers? Where are the numbers? That's kind of important, guys. Oh, there it is. Oh, there we go. So let's say this. Let's assume this is the thing that Bruce has used. I don't know for sure, but this might be it. 36.2. So we need to at least match that 36.2. So 2 of the 97 mil one would definitely blow this out of the water. I guess there's a diminishing return in terms of increasing fan size and airflow. So a stack of 2 97 mil fan will be better than one of these. But how many of the 75 mil fan would be equivalent of that? There's a map here. 6.2 divided by 12.7. 3. Why do I need to do math on that? So take 3 of this oh my god, 75 mil. Yeah, it take 3 of these to match one of these on top. What sort of that the 12-volt version of it is. Oh, but there's a slim one here. Only 15 millimeter. I want that version, but around that level of slimness. Let's keep going. Oh no, that's the one I'm looking at. I was looking at. Oh wait, no, what I think I saw something. 6015. 7515. 7515. That's the one right next to it before. So give me some number here. Huh? Speed airflow 6. Huh. It's like anything below 95, 97 is basically meant for very small case. It's not meant for moving a lot of air. It just created some airflow. Grab some water really quick. Yeah, so 97 millimeter fans seem to be at the sweet spot. Huh? So these seem to be the sweet spot between size and amount of airflow, at least from GDS. Maybe we can go for a 95 lower fan, 95, 20, 95, 20. Yeah, let's just have a generic search to see how that go. 40, 40, 40, 20. What's this? 97. Oh, this is we were already looking at this. Ooh, barbarian. What the heck? Why then? What are they advertising here? Just checking. I think it's the same thing, right? Yeah, it's the same thing, or yeah, it's the same thing, just with the grid. 50, 20. 97, 20. 97, 20. If we can keep it at less than around 20 mil thick, this will be great, but obviously it doesn't seem like we can kind of find that. Yeah, 9733 it seemed to be some sort of standard for something, so everyone is making those, but nothing in between that and a smaller version of things. Well, we only have 2 pages of this, so it's easy to just look through it all, huh? All right, we have made a very valiant effort to find an alternative, but obviously we haven't found any. So let's just work with what we have, which is 2 of these, and we want to keep this at 70 mil. 1 sec. What? All right, let me get a face full of box here, and well, it doesn't smell that bad. It does not smell that bad, but you know. Oh. Let's hope that I don't knock the thing out of the print, but that what is that is 75. It doesn't smell at all, actually. Good stuff from 3DQF. Good. Oh my god, I take it back. I smelled it now. Alright, so this is 75, not 70. That's cutting it really close, so not exactly thrilled about that. So we can do that there, like so. Yeah, so at least we got at least a 5 mil gap here, I assume, right? 33 times 2, 66. So we got 5 plus 4, so 9 mil of space between this wall and that. Not accounting the wall of the I think itself, so not exactly real. Maybe, yeah, we can play with that a little bit later. We can play with that. So yeah, we can keep that at 75 millimeter. All right, so how thick of the wall do we want? Diameter. Oh, the dimension. I mean, so make it 2 for now. Maybe 2 mil. Yeah, 2 mil is thick, right? Good enough, right? Hopefully. Yeah, just put it down. Okay. Like that. And now we extrude it downward. Wait. Oh my horses. I just realized I ran out of space. I want a funnel right there so that I can, divert the air somewhere using a toggle switch, much like the one on the Stealth Max right now. And I just realized that this space may not be enough. Oh god. How do I do this? Alright. Let me gaslight myself really quick again with how kind of straight I'm working with. Oh, and the print is done. $300. Let's say, let me assume now this is 300. Yeah, so we have roughly 100 for each of the fan and another 100 to whatever airflow guidance system that I want, airflow channeling system that I want. So that is gonna be the size of the box. But of course, obviously, this mean that this no, that's not too bad. I was worrying that someone may find it annoying to fit this into a what do you call smaller Voron, but then I realized I am not going to support anything below a 300 anyway. So let's keep it at that. Now we extrude it. We extrude this one here. Yeah. Downward, not there. Up, not up. Downward or up? Yeah, downward, downward. Yeah, downward. Reverse, and then give it 2 mil. Oh, 3. Let's give it 3. Let's give it 3 mil. So slightly thicker. Slightly thicker than the than the wall. Okay. Speaking of wall, I take it back. The wall here need to be 3 mil at least. So we can make. So and if we use the top and 6 and 5 layer for the top and bottom of the print respectively, so each of those layer top and bottom solid layer should be about millimeter thick. So if we do 3 mil, that's fine. Let's actually keep it for now. Not too convinced, but let's keep it there for now. We can hide. Oh, no, don't hide anything yet. And the reason why I extrude it downward because I want to use the same plane for something else. So grab that. No, we grab that like that because I find it very annoying. Grab that shape. Everything so that I can see what I'm seeing. I need a shell. So I'll just grab that, join these two, and for the print, I'm just gonna wait for it to cool down a bit before I touch it. Then I grab that, like so. 1 second thought. Let's use a centered rectangle. Because the reason which should be clear almost instantly. Almost. That and oh, don't merge the points like that, right there, and assuming that I'm still having the right, there we go, that like there we go, yeah. the center point is an extra thing that we can use to orientate all these boxes. Anyway, so we don't have to go and do that manually. Anyway, hide that, make that, go up. Now we shall go for 900 mil. Oh, so put a 0 behind that. An extra 0 there. So that is what it looked like. And oh my god, it looks so scuffed. Alright, yeah. So the space available for this to pull air in from is that plus that. Not exactly the most optimal airflow, huh? How we do this? Let's check back to the drawing really quick. Oh, should have keep the selected blower fan on its own tab. GDS fan. Hello. There we go. GDS fan. 9733. Oh, not that one. That one there. That one had the right plug. I don't need the USB plug. 12 volt, which is 24, but hey, bigger can be choosing. All right. So what I'm looking here is mounting points. Second thought. I just need to find it. I need a second thought on this. Giving myself a second thought here. Can we not make the fan diagonal? Yeah. Oh yeah. Yeah. Can we not make the fan diagonal? So let's just hide this now. Go back to this assembly really quick. Back to assembly. So I'm keep thinking about keeping these two parallel like that to the assembly, but the problem with this idea is that when you fit it into the box with that space there, you can see that you can try to fit the wall around them, the 3mm wall around them. You can tell that the gap here for the intake is minuscule. It's not good enough. It's not good enough. So what I may be thinking here is, I'll go back to the assembly here. So that fan stay where it is, because that is the only way that place it can be. But we may need to tilt this fan a little bit, right? Oh my! Grab that face and that face for now. We're making it. What other joint have we got? Nothing. Okay, the distance. Yeah, let's keep it as distance of 0. And now, why is it not applying? Okay. Big cat. You with me? Oh my god. It's not. God damn it. From that and that. Here. Come on. Why is it not working? Oh, maybe because I saw that one was in written. And so, come on, work with me here. Oh, I think I select that face, that item instead of this. Alright, there we go. Okay, let's just merge them up for now. Oh, and it's currently orientated wrong. Okay, and snap, transform, spin it around. It doesn't work. Okay, why when I spin that one spin too? It make no sense, free cat. You make no sense. All right, transform that. God damn it. Alright, need to do what I did before. Oh, it's gonna be a long day, isn't it? No, not bad. Of course, you need to. So, there's a refresh button somewhere. Wait, where's that? And so, why are you not doing it? So finicky. Okay. Okay. A little detour there. But we shall move this one up a little bit, back a little bit. No need to be exact, but because I'm gonna spin this at an angle, like so. Yeah, like that. That way we can, so that way, hopefully, can clear some distance. And I want that dimension from there to there to be within the volume of the box that we are putting it in. Actually, this one better off being the back one. Yeah, this one is the back one right there. I'm making that angle. The front one can be up straight. Like so. Yeah. Right. I think this works. Okay. Put back face back on, obviously. That photo does not work too well. Okay, actually, run back that really quick, move it out of front. And spin it again this time. Such that it fit into this groove here. Alright, roughly position is good enough. Roughly position is good enough. Don't break yourself, please. Yeah, just like that. Oh my. Yeah, somewhere like that. Okay. What would that give us? That's simply over-allocated. Yes. You know, the idea of using a brushless molder, a drone fan, to just and make my own fan seem to be growing on me right now. Not totally selling it yet, because 3D printed fan is not exactly known to be good. They're good gimmick, but they're not good. Like, not, it's good to put on a video and all that, but so the orientation it will be interfering with each other a little bit if I would tilt this one. But now if I tilt it like this, I can have more space, right? Got more space, but I think we need this thing to go forward a bit more, so we can have an adapting section. So this thing can go from this rectangle to become this pseudo triangle bit here. So we need a little space for that adaptation going to be in place. At the base, yeah, I think we have the space 97, so that's 3 mil of 100, and we don't need a full 100 for the what is it, flapping do that here for the air guide modifying. So I reckon I can do that. Yeah. Okay. So any second thought for myself, and say, how are you gonna put this together? No, how you gonna make this optional? That's $1,000,000 question, isn't it? How would I be able to turn this from because this config require both to be in place already, so we need to make sure that whatever we do next is it turn this from a locked in kind of config to be an optional one where we can have one of these fan and nothing and not the other one. So to do that, which one of, if we were to only have one of these fan, I assume the one at the front here would be the one that matter more, because it doesn't have to go, we don't have to duck it, we have to create a duck to touch between it and the outside world, right? So you can just blast so air can just blast straight out exhaust and go wherever I need to go. That one we need to make a duct, so it has to be configured. Need to bring this one up a little bit because this does not fit right now. All right, so in actual fact, I think what needs to be done is to have a cut. So we want to make a face. No, so basically I'm thinking about the mounting first. Let's think about the mounting, right now. Right, great. We can have this thing in like that. Cool. All right, good to know. But how are we gonna mount this these two to this box? And maybe we don't want to do that. Maybe we have one at the third piece. Yeah, I think about it. I think I can create a docking system first, to which both these fans can mount to. And after that, we can try to just put that whole docking system into this box. And that form both box. That way, we can map that docking system to be dedicated for one, to be made for one fan configuration or two fan configuration. And that will be the piece to use to reconfigure this to be a dual fan or a single fan. Yeah, actually, that turned out to be a good idea. All right, so behind the base, and you know what? I may need to grab a 3 model of this fan, because the centrifugal fan model. All right, I don't need this tap. I don't need to tap either. And also, can we not? All right, we use Brave because we model 3D CAD 3D model. Okay, we have GrabCAD. What's that? A 3D fan. Okay, lower fan. Do I have to make my own model? It seems like I need to make my own model. 97, 35, 33. Come on. Okay. What's my chance of this thing? Not what is no? We need an account to do this. Come on. Through you, I'm making my own. Why do you want an account? Now, why do I need an account for something like that? I don't get it. How we do this? Actually, let's download, copy the image, save the image, download for now, save that. Yeah, so I save that image, and I am gonna import it. So hide this reference as well. I'm gonna bring the fan back. I'm gonna use that image as a background for this thing. We know the dimensions, right? So wait, no, before we do that, let's mess with the image really quick. You guys don't see it right now. Let's save desktop. Not desktop. Open with another application. I'm going to use drawing for this, which is a software to manage image on Linux. So let me just show you that window, which is drawing. That one, yeah. And now make it bigger. I shall move this one. Oh, I have no clue what I had just done. Okay. So with this software, what I'm gonna do first is to crop it with that to just that. That's the dimension we need to grab. Oh my, yeah, that's not exactly the most intuitive system picture, but it worked. So do we need to save? Well, I want to save a copy though. Save a copy. Save as. Put into a the same thing but crop. Yeah, I want to keep a copy of the origin in case I need to work with it again. So I'm gonna make this a copy. Just save it as crop. See? Transparent. White. Okay. All right. There was some there's some error there. So I'm gonna do that again. Oh my God! Come on. Cancel. Okay, I can save this as a PNG. Save as. All right. I think I got it. Save. Oh, and stream just did something. Frame drop. Only 0.5% though, so that's good. I don't think anyone gonna notice, right? Oh, are you the one who I asked regarding low SDR on FreeCAD? Yes, that's me. That caused FreeCAD to lag even PC spec is high. Yes, that's true. That's me. Did you try the SDO yet? No. Yeah. Had you tried the step file yet? That was the thing that the advice I had back then, I believe. Save. We're done. Okay. Can we not just drag and drop it? That's my $1,000,000 question. Yes, but not like that. But I don't want that there. Ah, do we need to build a pan on upside down again this way? Can we give it a different orientation? Nah. No. Let's just try that. You know what? The whole point is to we are brainstorming, so I reckon rather than trying to fit whatever we're fitting here, cancel here. I'll put that there, yeah, but let's make another surface. No, not there. Stop doing that. How to do what? Putting oh my God, why is the stream dropping frame again? Yeah, you can drag and drop actually. Just if you have the step file, just drag and drop into whatever software you use. Is most of the time what I do all the time. So come on, get out of there. Fine, you can do that. And 97, 97, 33. Does that work, Anthony? No? Okay. That's alright. Alright. Okay. So my plane. Oh, that's my plane. Come on. Oh, alright. Okay. Okay. We need 97, so we need a line. We'll make it 97 horizontal. 97, 96. Oh, dimension 97. Okay, so make it the construction line. Maybe not. Okay, close. Oh no, not don't close, huh? And hide that for now. We need to increase the size. Now we keep doing that. Keep aspect ratio, yeah. So yeah, let's spam that until I cannot see the line. Let me just highlight it there. There we go. Okay. Oh, cancel. No. Okay. So let's grab the top again. Oop. Go in there. The line there now. Pixel to pixel. All right, just a little more to make it the same side. Okay, close that. I wish I could have made that line a different color. Oh, you know. Okay. A little more. Come on. Oh, there we go. There we go. Let's put it on the side here so we can see it. Oh, it's a little off. A little off. So just a little more. Yeah, that's too off much. That's too much now. I think that's about it. That's about right. Alright, so between that, so make that point. So add, rather than add 1 to that, I'll just 11.5, 11 but 0.5 instead of point, whatever that is. 4.5. Okay. That's roughly where everything is on the fan. Now I can do sketching. I start sketching now. Yep, that's about right. And that is that edge there. Anyway, I'm planning to do ROV submarine. Oh, that sounds cool. Jump into FreeCAD. Do I need to jump into FreeCAD for design first or start basic sketch using pen and paper? Up to you, man. No, so for me, no, so robotic is a different field, I think. So for what I'm doing right now with 3D printer and stuff, it's a different ball game basically when it comes to robotic. In robotics, there is a lot of calculation, of kinematic calculation. So you might want to do that first before you even trying to like do some work with the CAD. Because once you lock the CAD in, especially when you have a full feature tree, going back to the first sketch and fixing that, it's not going to be easy. In fact, that's some of the things that I have to do for MissChanger right now had to be done in V2 instead of V1, precisely because there are some sketch in the old assembly that there's just no way to fix it now, other than just redo everything from the beginning. So yeah, that's my advice on that note. If you yeah, no, on YouTube have plenty of people who are pretty keen to what is it? On YouTube, there are plenty of people who are very keen on robotic and stuff. So You may want to go search that up as well. Hopefully. And actually, let's try to use this thing now. I don't know what this do. Oh, wow. Okay. Oh, what the hell did I just do? Ah, it's fine, it's fine. Doesn't matter too much. Does not matter too much. Come on. Hey, that worked. It works. And this should be, oh, I should have added some more point here. Can I do that? Alright, I did. I can. Nice. Oh no, I cannot. Okay. So get rid of all that. Oh my god, not that. Okay. Get rid of that. Get rid of that. Let's try that again. I'll grab that. There. So about quarter every time. Yeah, let's do per quarter. Yeah. Yeah, I don't want. Let's not add any too much. Let's not add too much. And everywhere, but that's there, that's there, that's there. Oh my, don't do that. Right there. We go out a bit more. Go in there a little bit more. Yeah. I don't know why I'm doing this. It's not that necessarily, not that needed. But hey, it's my show. But my show is my stream, not a show. If it's a show, I will get paid. Not paying the anyway. Tangent. Can I make it a tangent? Yes. Nice. Make that in 90 degrees. So can I please select the line? Oh, it's already okay. It's already. What is this? Okay, what is this 1 mil? Ah, okay. Up. I hope this whole sketch thing is up to what's it? It's up to scale. Tangent. I think it is. So I'm not. Oh my god! Don't do that. It doesn't work. That one. So I'm just gonna not do that. All right. So that is the outline of the fan, right? Oh, all right. Before we do that, let's get on to that. Let's grab the plate on the off the bed first and see how that goes. What is that? Hot. Never mind, it's still hot. It's still too hot. I'm just gonna leave it for a bit. It's not that clear where this begin and end. Okay. Yeah, let's just leave it at that. Okay. So this is the thing. And to make sure that it lock this one in and that one in. Yep. Close that. We need to we need to make those as well. Oh shit. Okay. Sketch. So we just undo those last two. No, undo, delete that one so that we can cut right there. How do we do that? How do we do that and that? I'm gonna grab this here. So don't touch anything else. Like so. And now I'm gonna trim it. Trim it right there. Trim it right there. There. Oh my god, why are you doing that? Hopefully those two are actually connected correctly. A bit foreshadowing, maybe. And why this is not trimmed in? Was the last time I actually... Why not trimmed in? God damn it. Alright, it did connect correctly. So that's good. Just leave it. Come on. Trim it. Let me trim my... you can see the green little bit there. You can see the green. I mean, it actually detects the point where I need to trim, but it doesn't trim. Oh, failed to trim edge. Why though? Oh. Alright. Now we give it a point here. Give it a point here. Can I trim that? No. Okay, so can I split the edge still? Oh my god. Is that the reason why you don't want to trim? Alright. Understandable. I guess I build in these now. Let's build in the ears as on another sketch. The first sketch should be used to define that curvature bit on its own, instead of adding these extra feature there, which can be sketchy. So let's undo all that. Undo all the way to the oh well. Let's undo all the way to the lock. Oh, control shift Z, I mean. Yeah, that lock. Wait, what that lock? Yeah, that lock hit that in. And now I lock this in. Okay. Any last thought on that one? Actually. Alright, just move this one in a bit. This one down a bit. Yeah, and just shape the curve to be closer to each other. I swear to God, there's probably a that I'm sure there is some sort of mathematical equation to define this curve, spiral curve, but I don't know how. I don't know what it is, and I may or may not be very interested in that. So we'll deal with that when we got to it. Hey, we have to deal with it. Anyway. Alright, let's extrude that. I just log that into 33. 33 was it? Oops. Close that. Don't need it. Okay. Let's grab the other window. Let's grab the Amazon listing. Of course, this need to be somewhere down there. Yep. Oh, there we go. 33. Yep. And the wall thickness. What's the wall thickness? Yeah. Does it matter? It does, but not now, I suppose. Okay. Yeah, I'm just wondering how thick the wall of this the actual side of the opening, but doesn't matter. Doesn't matter. So let's open this big up and make this big again. Make this big again. Alright, I'm gonna extrude this for 33. 33. And now go back to sketch the plane, I mean. And we are going to make these ears. Oh, not that. Okay, we can't do it actually. Oh no, not yet. Let's grab that there. Put it there. Just mouse it that out. On the listing it said 4.3. What's that 4.3 supposed to mean? I think that's just a size of the hole, right? So that you can take it up to an M4. So I can take up to the M4. So it doesn't say much, if anything at all. All right, let's just cut all the way down there. There we go. So we can see what we're doing with, working with. Yeah, just rough sketch this all because we don't know. Oh my god. Okay. Let's put 2 circles here first. All right, I got 4.3, 4.4, 4.2. That's good now. These two equivalent to make them dimension 4.3, like that. Oh, and concurrent viewers. So we have 4 people viewing, and we have 2 likes. So if the other 2, if you're listening, this be much appreciated. You can help the channel with a like. Yeah, I think that's enough. Oh wait, no, have I done that already? All right, we did that already. So that should be where they are. You know, these holes roughly should be roughly where they are and is. So let's just lock them in like so. Yeah, so that we can move this in and out like that without breaking anything. And I'm gonna just define this, give it a number 4. Yeah, good enough. All right, how tall do we push it up? Back to the drawings. It does not shade, but I think it all the way up, right? Yeah, it all the way up from end to end, so it's 33 mil. Wait, no, that just. All right, so that can go up 2 face. Okay. Yep, like so that's that, and now we just need the hole in there. Hide that now. So now this is a time where actually, and I need to avoid this. No, I need to grab that face, add a plane to that, but I can work with that without worrying about things breaking in the future, and start sketching on it. I have a plane, of course, because it look ugly, and then we draw this circle here. Mm-hmm. 59.8. 59.8. How nice of you to give me that number so easily. Oh my, don't assess the sketch yet. Okay. So clearly the opening is slightly bigger than that, huh? So my my measurement might be a little bit off. Just a little. So I reckon it's fine. All right, lock it in, punch a hole. Okay, so this is the part where we might need to dip the. Oh, this is the part where we might need the the thickness of the shell, but no matter. So we're going 32. Yeah. So that I have at least 1 millimeter. Make it 2. Make it 2. It'll look better if that's 2. Yeah, so there's a 2 millimeter between that surface and the bottom, just so that it doesn't. Oh, thank you. Yeah, so there we are. So that's our fan. Scale and in the model, simplified model, but and may not be completely correct, but it's a start. It's a start. So now we need to rebuild this assembly because do we? Yeah, we do need to build an assembly, but not in the way that was thinking before. So let me just So we just underscore this mockup 1. Oh, mockup underscore 0. Yeah, it's not even a mockup 1. It's just literally just me brainstorming there. So just leave it at that. Put this fan footprinting here as well. Actually, I don't even need this. Get rid of them. Yep. Yes, please. The base can be the base. Reference. That one coming in. That one. Oh, that reference. That is a reference. Yeah. So the picture. Scaled it picture. Scale the picture is there, and we'll throw this one in a sec as well. But you guys may notice before, if we make an assembly, it's best to do it before we put it into a folder, because as of right now, the assembly, and it's not a bug, it's actually, they did mention it straight on in the documentation, that the assembly may not be able to pick up item that is in folders. So right now, if you want to make an assembly, you want to keep these on the outside, and then you can import one of these like that. Okay, save that, because assembly workbench is not very stable, and you're gonna hide that so that we can see the assembly itself and only the assembly. And another one. Okay, and then just move it first. Yeah, move it out of the way. Okay, so that's the first one. So that we have 2. Now, we need. Oops, should that mute? My bad. And in light of that little coughing spree there, I gonna get some water and get some cough medicine as well. One sec. Good. That was a good. I actually did mute myself, so nobody could hear myself talking the whole time. That's good. Oh, and also I heard the before I go away from the BRB screen, I'm gonna grab the part of the bed there because I can hear the crack. That means I think it's separate from the bed. I think on its own. No. Well, so to remove the brim as well. Don't want the thing to interfere with the next brim. Come on. You gotta be kidding me. Sometimes it's well to sell in place and it come up next time. It come up the bed with the next sprint. But I'm still up the next sprint, but it's good. So this is the back panel. Now this gonna work. So we're gonna have this thing here like so. The reason why I even print this out is actually I need to grab myself an M3 by 30 and test if the hole is big enough. One sec. Got a one here, but it's a little occupied, so I need to grab it. Oh, there. Commenting on my hand. There we go. Oh my. Better jet. Little shaky. Alright, so that's just this one is an old one, don't worry about it. This one is the new one. It's gonna go like that. Be like 33, go through like so, and I need to screw it. Okay. Screw it in? Maybe. Shouldn't be. Oh wait, no. It'll fit right through. We just need to line them up. So. Oh. Not like that. I need to make room for the other one. Ah, come on, buddy. Push that back out a little bit. There we go. Now this screw does not need to be tightened at all because when it don't come into the machine, this part here will cover up by the 2020 extrusion. So the moment as long as it can go in there and sit in place, oh, it's good. And as you can tell, this thing gonna sit in the back. Oh. This thing is sitting where the orange bit was, and it's gonna be like that. It's gonna swivel in and out. Swivel in and out for the umbilical and the PDFE tube. Oh, and picking up the PDFE tube. I've got a little one to mock up the how it's gonna play out as well. Right there. Obviously, there will be a box at the back so that the BFD to have room to wiggle around when it's installed. But that's there myself, so I'm gonna like that, right? We may or may not need a little spring tension to keep this thing at the back like that. But I think as it is right now, it's good enough for testing, is what I would say. About that. So, that's all there is to it. Okay. So now let's go back to the designing of things. Oh. Out of the main screen here. Think about this now. Right, so I need to determine the angle of which this thing is gonna be tilting. To do that, I reckon I will have a sketch. This one is gonna be weird because I'm gonna have a sketch without and so that's it. A sketch without a body. This is well, what's the correct term of this? Oh, it's a master sketch. That's what they call it. That's the sketch that everything else work on. I don't use it too often because they are that I can't wrap my head around it. Can't wrap my head around it. Okay, yeah. So if we wrap it around an XY plane, just this one would not constitute a we're not going to extrude, or we're not going to make anything out of this. Really just to define the boundary of which the fan gonna sit in on this specific plane. Not that. I don't need a center one. I need a rectangle, normal rectangle. So we grab, just put it down first. Put it down first. Oh wait, no, center one actually. I took it back. I need a center one. So, and I need to see the sketch first. Like that. And the wall need to be 3 mil. So just grab that, put it there. So up like that. Make those two equal and equal to 3 mil. Yeah, I find 3 mil to be the right about the right wall size to marry between still thin and comfortable enough to do no, thin enough to not be chunky and weird, but thick enough to actually have some structural integrity. So now what we're gonna do is to draw is to use this tool here, not a square. Why you call yourself a square? But no, full corner system like so. Oh yeah, it is a square. All right, so we get rid of these to make these two equal. These two equal. Right. So right, yeah, there we go. That is gonna be the size of the trying to mimic the frontal placement of the fan there. So the height here is 33. That is 97. 97. Okay. Why do we need a circle? Let's just get rid of the circle, see how that go. Don't need that. So it needs to be normal. Yeah. And that's it. Okay. And of course, we want it to be fit into this box, of which is starting around there, I suppose. No, I'll start from here. Let's start from the bottom. Because the bottom you cannot touch. So let's start from the bottom. Put it there. Collide. Do we collide that? Yeah, we collide that. And then we go in a little bit. I don't know the distance, so just roughly. Just like everything we're doing today. It's rough dimension there. That may not come back and bite me in the ass some point later, but not today. Oh, and the outer diameter here is restricted to 80. Oh yeah, the machine is free, so I can poke my tape measure in. One of the key things that need to be done to pop it out. This plate, as you can see at the corner here, is bigger than the size of the bed. So if I need to make sure to move everything to the corner, one of the corner, like so. I can actually measure against the edge of the bed, not the edge of the build plate, of this oversized build plate. This. Oh, we got about 80 mil, not 70. Put it up, 80 something. 80, let's say 84. We got 84 mil between the acrylic floor and the bed. So I got 1 mil. I'm gonna send this down, the battery down for the eagles. So this wall here can be 84. Let's go for 80. Give it 2 mil on each side to not touch anything. Dimension 80. Yeah. All right. So how far can this box tilt, but while still within this volume? That's now my question. All right, that one gonna contact oh my, what did I just do? We interact with that line like so, and that one can go up there. Come on, like so, like that. Yeah. Okay, so what's this angle? Dimension. Reference only. Okay. Like so. The height don't matter too much, so we just gonna. Oh, but actually, I do want to know. I do want to know. So, what is the effective volume now of this thing? That's gonna be annoying because that I don't need to know. Okay. Yeah. Well, let's not bother with that right now. It's not worth it. So this and that and that and that. Let me them not construction line, because I actually do need to see them when they off like that. Right? Why you purple? I don't know. But it's not breaking anything, so I reckon I just keep it at that. And now, ladies and gentlemen, let's see if this thing actually still broken or not. Okay. Alright, now actually, let's double click on this assembly so that we work with the assembly. I want to move this piece. What's this one, by the way? Explore the view, so I want to work with this piece. And I'm gonna move it around. Oh, hey, it didn't break. Can I control the amount of tilt it got or no? Because I don't see a dialog box. I don't see the dialog box on the corner that allow me to fine tune the angle of which this thing is tilting. Oh, now that's annoying. Why is transformation doesn't? Okay. Let me try. Transform. Yep. Increment. There we go. We'll work with 1 degree, right? That work. Now for this, I'll get 0.1. Yeah, that's good enough. We don't want to go off deep in. We don't want to go off into the deep end in terms of like accuracy and all that. Need to give ourselves some room of error. I don't know why that dialog box didn't show up until now, but hey, it's showing up now, so let's not worry too much. Alright, that's that parallel, right? Now we can grab that, put it there like so. Oh yeah, not that like just yet. How about now? Yep. Oop, a bit more. Okay, I take it back. 0.5 degree. I can see the problem, so I can't unsee it. I cannot unsee the lack of. Oh, come on. Maybe I should define this angle instead of, Nah, it's good. It's good enough. Good enough. Just like that. Wait, why is it? Hello? Why does it have? Why does it have to? Oh wait, no, yeah. Okay, yeah. Oh well, what? Really? Am I crazy? Why is this showing up little corner over there? Whatever. I don't know. I don't know that. Why? I don't know why that there's a corner out there. But I think this is good enough. Yes. Yeah, that's good. Don't overthink it. Yeah, all right. This will be the rough position. So, you know what I'm saying? Hmm. Hmm. So what's the idea here? Oh god, I may have to use it. I might have lost my marbles there. All right. Oh yeah. The reason why we're doing this is because I want to create a duct. The duct is a thing that will allow us to configure this to either one fan or two fan. So and what the whole exercise that I had done just now is just literally just to get this fan to tilt at the right angle, roughly the right angle, and we can measure other dimension to let it fit. Obviously, now that we have got this far, we need to think about how exactly that docking system is supposed to work. Because ultimately the idea would be the area of this stay the same throughout the duct system. So if I make a dimension there, so it's 19 centimeter cube. That need to be the same all the way through this. Does it need to be the same? Wait a second. I'm just gonna write that down quick, please, before I talk really longer. 19 centimeter square. So that is the area of that little excess edge of the outlet, and I need to funnel it under this and then outward. Here is easy. Oh, here is easy. All right, I can do that. I can do that. Wait. Because that one is easy because we already had the master sketch, which is reset. We had a master sketch there, so we know where the boundary of the wall is supposed to be, right? So we just need to make some mounting point here and here to allow this thing to be screwed into the duct. And no, there will be no duct here for this one because it literally is right next to the exit. So that is in the third system on the corner here. So that's not this completely a completely different piece. So we just need to put in place some mounting point for there to be a two bolt coming through here. Most likely M3, but it seems like on the website it says something about M4. We'll see. But because of that, I reckon grade the body. Fan. So which one is this one? This is fan 2. This is fan 1. So fan 2. Let's call this fan 2 mount first. And 2 fan 000. They're just copying the name from the top. 002 and mount. Right. And for that sketch, I want that as the reference point. So we can now hide that. And actually, we can hide the whole assembly. And now, yep, it's good to see the sketch still at the back. We are going to grab. We need this point, that point. Well, we need this. All right. This surface is coincide with the edge of the wall, so that's good to know. The edge of the wall of the box that this going in, so that's good to know. So we definitely do want that surface there to be able to extrude stuff to it, or to extrude out from it. All right. One sec. Let me think this through. Water first. All right, so we definitely do need that surface, and we need to extrude whatever that is to that one. All right. We also need the front bit so that we can create a wall around here first. Oh yeah, let's do that first. Let's do that first. Uh-huh. Because no matter what, we're gonna need that surface. Yeah. And then the point of this one is make a render blender, draw on it first, hide everything else. Oh no, we do. Oh no, no, that's fine. The point here is correctly placed. So no, I don't need this one, and I'm gonna grab the edge of this piece. All right, so that will be the hole that we need to carve out. Grab that. That's the opening I meant for the. Oh no, not that. Oh no, not that either. Okay, actually, let's just draw the shape. Oh, draw the shape. Yeah, that is the hole that we needed for this. We might want to add some. Oh right, we might actually add. Yeah. I take that back. Right. So I'm gonna grab. Okay, I'm gonna grab that. All right. The angle the square. Right, so get rid of the equivalent bit here. That should stay, but these two don't. 6. That one and that one should be equal. I don't know how this one does not. Just put a normal here and get rid of the circle. I still don't know how the circle allow me to define. Oh wait, and I do need a circle. That's half the reason why I did it this way. Okay, never mind. I don't know how this circle allowed this to be, what is it, to be for these to be a right angle. Still don't know how. But it is, so let's not think too hard about that, I suppose. I go for an easy solution. Not thinking too hard, I mean. Alright, that one should parallel with that one. Yeah. Go down in size. Yeah, alright. So I want a distance here. 0.2. Okay, let me give a 0.2 on each side. That's 0.4 in total in terms of difference. But that's 1.2 instead of 0.3 so that I can go in snugly. And also the print orientation on this is gonna be weird. So that should be reasonable. Then the other thing that we need to do is actually may not want that edge. We want it to actually we want that surface. We want that surface. Yeah, we do. So that hole is going to be cut out, right? We do. No, I don't want that surface. I want these two here. So those are where the bolt gonna come through. So we definitely need to create a leg going through. So come through from that side, coming up, right? I'm not feeling I'm overcomplicating this, but so well no. So let us draw something really quick. Grab that. Just draw a box around here. Yeah, that one is over a constraint, that's for sure. No, get rid of that. Get rid of that sketch as well, because now I just defined it. That should work, right? Right. There's no high limit on this, so I'm just gonna put it there. I mentioned that, like so. Yeah, let me get 100. Yeah, make it 100. No, wait, 101. Okay, there is a high limit. We need to fit the thing inside the thing. So let me 101 for now, just to give it oh wait, no, why is it not? Okay, whatever. Fine, you get 100.8. So if we exit this now, put this away. Okay, that didn't show that well either. So we let's close that. Oh, okay, I see it now. If we put that line away, man, this 0.2 mil gap gonna drive me crazy in a bit. But that should be the shape of the baffle system. Reverse that, make that what? 4 mil. There. I should add a little bit on the corner here as well, but I reckon I can build that into the base bottom, the bottom bit, rather than into this bit. Or should I? Yeah, I can do that. Yeah, it can be done. No, I changed my mind. I changed my mind. Don't want that point. They'll be there. That. Ooh my. Okay. Rid of that. Put that back where it is. So, yeah. Go up, please. Go up and go over there. Yeah, and I can now turn this back to a normal line set of construction. All right. And this distance here is gonna be how thick the base is supposed to be. So for now, let's give it 5. Give it 5. Yeah, it's gonna bear weight of quite a bit of things, so maybe 5 is good. And why are you screaming at me? Can I not? Oh, right, because of that. Okay. Oopsie daisy. Told you this 0.2 millimeter gap gonna drove me crazy. I knew it. And what did you just do? Oh, come on. Can we? Dimension. There. Alright, that's that. Alright, once again, let's define this now. This 105. Point. No, 106. 106 is this. That's good. Okay, extrude that. Reverse for 4 mil. Oh, 10 mil is fine, I suppose. A little thick and unneeded. That's 10 mil. Wait. Make it 5. Make it 5. Give it 5. I like number 5 for some reason for today. Today I like number 5. Alright. Remember, I will still need to cut out a little gap down here for the other fan to pass through. But that is in a bit. That is to be done in a bit. How do I make that, actually? Yeah, I can actually. Yeah, no, it wouldn't be that hard. Yeah, don't worry myself too much. Need to make the mounting point for these two first, and then we'll figure out the rest later. And to do that, we need to draw a plane first. Wait, do we? How are we doing that? Now what is the fastest way to do this? So we grab that plane, create a little square, triangle, whatever that's called. Rectangle, yeah. Draw a little rectangle, and then we extrude that to that face. That should do it, right? Yeah. Or alternatively, we can draw on the same plane. This one. Yep, and get rid of that. Okay, don't get rid of that. We can grab that plane, and we know we can draw a little. Yeah, we can draw the shape out right here. Yeah. Okay. Of course, I need to hide that away so I can show reveal myself. Oh, not that one. That one. I can grab that line, and that line is already defined. Don't need to do that. So I can draw a little triangle here because there are multiple things at play, so I don't want to over constrain it out of the bat. Just want to grab that, put it there. We bore the hole out later. So grab that. We bore, with that in mind, we can just wrong angle. Oh. We don't want that. We don't want this. We want that line. Because once again, the 0.2 millimeter gap for the this thing to fit tolerant. So okay, and we're gonna extrude it at least up to there. So that's a reverse, and I'm just gonna scroll. Good enough. Yeah, good enough. That's good enough. There's no specific number right there. Yeah, that's 99. Okay, fine. So that now we can hide that and hide that because we want a random plane here. So that we can now drill the hole out for this hole. Hide that, draw on it. We're gonna grab these two. This is the point where I need to make the decision. Are we going M4? I think we go on M4. Yeah, we go on M4. Wait, why do I get out of the sketch? No. The size of this hole are literally irrelevant because we're not using the drill and we're not gonna use the cut function. No, not the whatever. I'm not gonna talk anymore. Look at the equivalent. Okay, we're not gonna use this cut function, pocket function to cut it out. We use the hole function. Man, I almost thought that was a CPAP blower. This is a lot smaller than a CPAP blower. I can tell you that much. Wait, CPAP blower? How big is a CPAP blower? Wait a second. CPAP. Oh. Copy that. Because I'm pretty sure Big3 Tech got one, right? BTT. Not Bitcoin. Yeah. 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 Ooh. Come on. Oh. What is it called again? CPAP. CP. Oh. AP. You're not making this easy. Come on, Mike. What's this? Picture check. CPAP blower. Okay, let's go all the way out. No. So, oh yeah, so in case you're wondering. Oh, 70 40. Okay. Actually, the thing I need is the biggest thing that I need. Actually, that what was I saying? No, that's actually a very good number. I want to use that, but that's the right fan side that I wanted. But the other thing that I need to know now is the airflow. How much air can it push? So just so you know, the 9733 that I'm modeling with right now can push 29.4 CFM, and I'm coupling two of them together. I want to couple up to at least two of them together, so double that. So gone down to price and in airflow. God damn it! Come on, why are you not giving the number? And also, victory tag CPAP. 14.7. 14.7. Right. So let me read off my note here. A one big blower axle. Yeah, I think blower or axle. Oh no. Yeah, I just call it blower. Everyone know what a blower fan do. One big 2020 blower, so something like that, but 2020. So that one, yeah, that one can push 36.2 millimeter, 36.2 CFM. Obviously, this one is huge, and trying to add it to any system is not that easy. Yeah, yep. Thank you very much. Right, this one, yeah, some 35 36 CFM on this 2020 120 fan here. This is the fan that roughly the same size and capacity fan that Prusa use for their HEPA filter. I don't have that kind of space within the chamber, and also trying to, also given the airflow here, if we it is actually more, we will get more airflow if we have just two of these, 9733. So that one there, so that one there is 29.4. So we got two of these mounted together. That's like what, for nearly 60, 55.8 CFM. So two of these is better than one of the big one. And that one you just give me the 7040, that actually a good size, because the if we go to this one here, so just put this one a bit bigger, and I regret moving the gantry down. So the edge of that bed there, if you can see it, the edge of the bed and the panel is about 80 mil. So 70 is just enough to lie flat on the bed. Oh, no problem. I'm the dude that been wondering aloud if some hybrid between click changer and MissChanger is possible. E.g. CPAP on common carriage, but less fancy on a bill. The reason why the fancy bit of the build is a bit of a challenging thing to work with is because currently there is no like two-head system that has CPAP, and no, have a CPAP for one and CPAP that mount from the back for two. Not for a Voron. We can do that. If you want to go for that, you might as well just build a rat rig and then build a two changer around it, because that one has a CPAP that mount on the other side of the X gantry and go below, and it's all figured out. So building a two changer around that would make it much more straightforward than trying to get one on a Voron. So yeah, so that's my 2 cents on that. Obviously, I don't have a rat rig, and yeah, tough, life tough. Anyway, wait, what's the do we have a pressure here? A pressure number? No, we don't. Okay, we just hope that the CFM is good. That's the CFM is all we need. All right, I'm gonna copy the blower dimension there. Put it there. See how that go. Oh, hello. There we go. It is huge. And what the fuck is this price? Oh no, it's like a kit, right? This thing. That's why the price is all about that. Here we go, it's cheaper. There we go. Okay. Okay. That's the save potential. Oh yeah. Current, yeah. Speed, yeah. Static air. Yeah. So this is it. The price is double. Yep. What's up? So that probably the no, I'm just using Amazon because it's easy to search here. Now I don't want to buy a fan of my AliExpress, man. Or literally every single one I bought is all broke. But anyway. Let me read this. Airflow. They use a different unit. 25.5. Airflow 25.5. Now convert it in a set. Air pressure, that's nice. 25.5 meter cube per hour. Oh, per hour. Meter cube per hour. 2 CFM. 2 MCFM. Converted 15 CFM. Yep. About right. 15, 14 CFM. So let's go back really quick here. Compare because like to like on Amazon. Yep, so good to know. See, good to know. This is, yep, so this one is in 53. And then what, 14, 15 CFM. 53 pound, 15 CFM. So 15 CFM to get to 36, it needs 2 of them, obviously. Two of them, just 36. So 2 of these will be the same as one of the big 121 in terms of CFM. There's this one definitely had, this one is have more static pressure, I think. And it's look better, so we got that going for it. Oh wait, the wiring. There's so many wire here. Oh yeah, because the CPAP need a different wiring scheme, right? Yeah. They need a different wiring system here, I think. That's alright. That's something we can work with. 2 of these. So we do. So question now is, do we want 2 of these or 2 of the other one? 2 of these. No way. If we get in 2 anyway. What am I saying? Also, yes. Once again, I should have put the other one in a. They usually a separate dedicated controller. Yeah, I remember that being said at some point somewhere. Alright, so I'm just gonna grab that really quick. Grab that, put it there. And I'm going to open that one. What am I doing? There we go. Like that. So that I can keep that one on tap. This one here is need to be, this one is like what, 20 quid? 17 quid, 52. Alright. I know what I'm going for. Yep, it's a good thought. But thank you for the information. I definitely I'll keep that noted just in case I ever change my mind and have 2 of the CPAP instead of 2 of these. But if we have to go for 2 anyway, then it's better off to go with this. because one power cable, same two lit power cable, so we don't need a separate controller. And two, it's cheaper. Click and chain designer is pairing, then yep, that thing in an enclosure. Yep. Oh really? Yeah, well, god damn, how do you follow click and chain, by the way? Because no, because it's the same person who Vitis. His name is Vitis. At least that's his profile name. But anyway, he's also a designer of tap changer, which is the original two changer on Voron. There are some others. Well, that's the first one. There are some others two changer before him, but that is the first one that you can say that is a two changer on Voron. Okay, so yeah, it's really hard to get a hold of. Not gonna lie, which is all some at one point. Yeah. Oh, okay. You were following the GitHub. Okay. Yeah, which is the I can't blame him for something like that. Never mind. It's an open source project. We're not earning any money, so you can't say anything about people just disappear for a while. But at the same time, if you're the lead of the project, you really need to you really need to tell other people where you kind of inform other if you are gonna take a break away from a project for a bit. Otherwise, nobody know what to do. Yeah, yep. I am aware. On the EBB32 then. Funny enough, that's the it will work on what I'm doing here, but I kind of not want to use it. Not because of anything wrong with the specific system, it's just that the fact that it mounts at the back of the motor. And yeah, not the best place to mount a motor in a two changer and mount a controller in a two changer. It's like the third most expensive thing on your system. Don't want to be in line of fire when if some crash happen and your EBB32 just gone dark. That would be a really bad day. Well, what was I doing? Yes, I was going to draw these. All right, yeah, we're going to bunch this through. This is what I was doing before I went on a tangent there. Before the threaded was no. We are not doing that thread ourselves, so I reckon I'll put this slightly higher. Still too big. Not still too big. Thank you. No worry. Cheers. You know what? Actually, I'm not gonna go with this. I'm gonna give it a specific number myself. 38. Yeah. Just got some room for thread, but not too much room. Where did it go? Hello? First? Alright, well. How deep have you gone? Yeah, let's just have it all the way for now. I don't see a problem with that. And by all the way, I do mean all the way. So come on. Excuse me. Good to know the point. Thank you. No worries. Alright, where was I? Yes. So that's the hole. Alright, the reason why you may not want that hole. Oh, no. I'm fine with these hole being there. What I want to do now, is something I want to test for a while, is this other thing here, the skin function. Not R, intersection. Can I do that? Select. Yeah. No. Okay. Give me 0.4. Can I do that? Hello? Hello? Intersect? Don't pack? Alright. No. Okay. I guess it's not gonna work. God damn it. Oh. Alright, just keep those all for there. Oh wait, no. So keep those whole. I take this back on this hole. You want it 5 mil. Attention. Give it you 5 mil. This is 33. So an M4. What kind of M4 do we have? Nothing. We don't have any M4. Shoot. Let's sub that into an M3. Let's see what kind of M3 do we have. So we got M3 30, 35. Oh, we got M3 25, 30. That's the highest. That'll be a bigger. Oh. No, it's gonna get big. We got M3 40, 35, 40. Okay. So I am good with that. So if we're gonna make swap it up on M3, so I say 29, 2.9, 2.9, and right. Okay. And I say, okay. What do I say? This one I want to go down a bit there, but then add up to 33. So definitely we're more than 33. We're going to M3 40. 40 minus 33 is 7, right? So do that, give it an 8, so give it an extra millimeter to not I guess there's a potential problem there. It went through, it shouldn't be, but it did. So the total transparency to see where that hole is. We might get away with it. So just keep it for now. But anyway, the reason why I was planning to use a skin function there is I was hoping that I can just bore the hole out and it would help this. I was hoping that this function would allow me to bore the hole without and dodge all this mounting point for the fan, but clearly it didn't happen. So let me just put these away, and we'll talk figuring other things out. So now I bring the other fan into the bowl. Wait, what's the area of this thing? Yeah, that's 21.44. 21.4. So that's smaller. That's bigger than the 19 centimeter cube square of the exit point of the fan, so that we do have some room to work with there, definitely. Just making sure that we can handle things right. So how the best way to do this funnel? Oh, I might want to delete this hole. I want to keep the sketch, but I want to delete the hole. Cancel. Reset. Okay. I want to delete the hole, but I want to keep the sketch. We can bore the hole later. I want to make the mount for the second fan first. Speaking of the second fan, though, this may be just a perfect place to leave this specific object, because in a single fan configuration, this will be the single fan. In a single fan configuration, this will be the single fan. So I wouldn't need to board that. Do not make the oh my god, words. I would not need to make a whole a pass through for the second fan beyond if this was a single fan config. So I say what I'm gonna do now is I'm gonna put this away, and I want to make a clone of this. So instead of make that a fan 2 mount, I copy that single fan 2 single. I'll call it the single mount. No, don't say it. Fan mount template. Yeah, because we still need some work to get it to the one that we want. And this one, to clone of it, is going to be pass through template. Pass through. Oh, do a fan mount do. Yep. Mount do. Alright, like so. Yeah. Alright, let's try the skin function again one more time. Skin type in the set, and put this to 0.2. Put 1. Would that work? It didn't work. Failed to make. Oh, why did you fail? It was as easy. It's a very easy shape to cut. I don't get it. Maybe. Nope, that doesn't work either. Point 2? Is that the problem? No. Why did this does not work? I don't know. Get rid of that. Alright, I'll build my own hole. Fine. I'll do this myself. Oh, actually, before we do anything, should have done this. Let's have a sketch there. And we grab both of this. So grab that one. And that one. Like so. So we know where everything need to be. Okay. So think it through real quick, just in case we need to do anything. Oh yeah, how I am gonna mount this fan is still a mystery, because if you put a oh no, it doesn't show. But if you put a imagine put a case over this, yeah, I wouldn't know how to mount this into the side of the wall. And now that I mount this, wait, no, wait, no, wait. We can countersunk that, and we make a mount on this side of the assembly. So instead of mounting to the back there, which is like what, 3 mil. That's an ambulance. Instead of mount this into the wall that it's leaning on here, we mount it toward that side, because this side had more meat over here, so we can add a little standoff and all that to mount this. Okay. Alright, so that actually turned out to be easier than I thought. Alright. By the way, how long have I been streaming for? Oh, I've only been streaming now 3 hours. Was good. We can make another one, I suppose. Yeah, 6 o'clock. I'm not hungry, so we can keep going. Okay, where were I? yes, we will drill a hole through this hole and make sure that it's more than 19 centimeter cube. And to do that, I first need to hide that. Need it. Put a surface here. That might come to bite me in the ass in a bit, but not a bit later down the line when we if we ever need to deal with do something on the template side. But that would be a good place to be angry, to stop and be angry at FreeCAD. So content, right? How's the fastest way to do this? Grab that, make that hole. Actually, that's not a good idea. Take that back. Oh, no, not without the line. With the line. What's that? Yep. So we'll grab that, and there. Okay. What can we immediately define here? All right, dear. I want to make sure that these walls here are, that is, actually we can get rid of the bases. No, we keep the base for now. I need to grab some dimension off that, so I don't want to get rid of it just yet. Anyway, I'll grab that, make it that, like so. So the first thing I want to lock in now is the thickness of this. Right? Should I do that? Oh yeah, the base right there, right? So main want to normal. Put a normal there first. I want that wall and that wall to be equal. Yeah. But that one maybe just stick with that edge. Oh god damn it. Oh right, almost screwed myself there. Wait. Are we printing the whole thing out of one piece? I have a feeling I'm gonna have to print the whole thing out of a single piece. How are we printing this? Yeah, that's actually a good question to ask. At this point, so if we face it on this surface here. No. Actually, no. I already know. We lay it in this direction here. We'll put this on this side and bring it upward. But if we do that, this piece cannot be the base piece because this piece is just because that orientation. Because is it? No, should this not be that? Huh? I'm trying to think. Oh, why would we don't want to do what we want to do now? Oh no, we done doing what we're doing. But what we're doing is we're creating a docking system that will place it into a base, right? The docking system is where everything mounted to, and then we're gonna drop everything into the base. That way we can hide all the screw for one, and for two, that will allow us to configure this to be a dual fan system or single fan system. Yes. So that's why I should leave a larger gap down here so that I can cut into this. Oh, I need to cut into this and create like a interface between this and the actual base. Because that way I just ignore it and hope for the best. Should we ignore it and hope for the best? That last one was also mentioned. Speaking of ignoring it and hope for the best, I am having second thought on this wall here. Right? Because if this is not going to be the outside box, then there will be 4 walls. There will be walls on each side of this. We can just not. So we can, rather than having this wall, we can just have this. Oh no. We do need that bit. We just don't need this bit. Yeah, we can have this. I know we don't need to see that. We can have this touching that wall. How would this look in the how would this look in when we actually what's it called, do the function to connect the two pieces? I'm gonna connect in a bit. It's gonna be interesting. Oh no, does it? It may not be. We'll just we'll see. All right, this wall, let's give it 3 mil. Yeah, 3 mil. Oh yeah, this need to be thick enough to take this screw. I mean, oh, does it? No. Just keep it 3. Keep it 3. And if only there is a way for me. Oh, well, this one is not connecting. Get rid of that. Get rid of that. Yeah, there we go. So this. Oh, come on. All right, so this and that. All right, that dimension is, keep it 3. Keep it 3. We can do, yeah, keep it 4. Keep it 4. Give it 5. Give it 5. Yeah. Close. Oh, 5. Yep. All right. So that's that. Yeah, just so that we go here in little same bowl part of the excess that we put down here for now, and we trim that down later, because I think I need to trim that down over up to there. We don't need this extra bit. That one is gonna be done by the base, not this thing. So we move that up a little bit, like so. Close that. Just cut that first. Yeah, we don't need to deal with any of that, the other number really for now, because what I want to know is how big is this. It's 14.3, not good enough. So immediately have to go back in there. No. That. Right, go back in there and increase the size of this. Like so. How big is it now? 15, not good enough. Okay, this we may not have a choice on this. Yeah, we may not have a choice on this actually. So reduce this to 3. 16. We need 19. Yeah, no. We need 19. Oh my, so it's going to be close. At least 19. So we don't need to be exactly 19, but higher than 19. And why are you? We may not have a choice. We may not have a choice. Oh, no. We may not have a choice on the size of this at all. Okay. So reduce this to 2. Get that 2 as well. And push this all the way there. Yeah. Oh, actually, do we need that bottom edge? We don't we? Do we? Okay. Well, no, we might need it, but okay. I'll explain what my thinking in a sec. Right now, let me just do this really quick. See how hard do we need to get? God damn it. Save. Close that. So I'm here to hope that it may not. Alright, just give me a triangle. If we can get away with less aggressive dimensioning, then we can. But so I want to get away with this so that we don't. So we still have a lot of meat around the ducting system to work with. But if not, there are other ways to do this. Can we refresh that, please? Yeah, no. We need to think of another way, because this is already at the point. Oh wait, no, wait first. No, come on. So where is it? Oh, come on, reset, close. Get rid of that. So instead of that, I want you to cut that one logo off too. This is not ideal because now they literally only this one little slip of material here that connect everything. But would that help still? Yes, it does. Good. Not the best thing to print, that for sure. But we can work with that for now. So I am into project through. Okay, can I increase, at least increase that? Oh, can no. Reset. Come on. Reset. Get out of that dialog. Increase this to 3 mil. 2 mil is very thin for a layer stack like that. This orientation. So I want 3, if not 4 mil, because this is actually, yeah, no, even 3 mil ain't working. All right, so no, so we do the other way. So what I'm gonna do to increase that size is actually with this sketch here, which is a template. Okay, reset, close. With this template here, so this padding, I think was that one. Yep. So we're gonna increase this here. So in actual fact, we just basically just push the fan at the back, no, at the front upward a couple millimeter. So from 5 to 6, up to 6, like so. Yeah, so we have more space at the back here to cut off and make this bigger. Hopefully that makes sense. And why is there a sketch in there? What's this sketch do? All right, that one. Okay. Oh, no, you don't need that sketch. Okay, we'll do that. We get another one of those later. Now it should be. If only there's a manner that I can grab it. Nope, not that one. That one. Yeah. Oh, so close. So close. Actually, I think that I got it. Did I? No, let's just keep it 1 more mil. Come on, it's fine. No. Okay, give it 1 more mil. Make it 7. Close. Like that. So that way, now, so that way I can try to put it at 4. $18.4, take it back. Okay. No. Okay, never mind. Come on. No. Okay, put it back to 3. We'll figure out some reinforcement later. Close that. Measure that. 19.3. Okay, that's good enough. We'll keep at that. So this pocket is going all the way through. No. No, come on. Get out of that. No. Get rid of that. Alright. This pocket. Up to face. That face. Yep. And the reason why we up to that face, or do we go all the way through? Up to face. Yeah, let's just go all the way through. For now, so this is the first piece, right? Alright, so before we move on, that is the thing that we're gonna drop into place. Before we do that, before we move on and make the mount of this, we need to drop this down a little bit. I want that to match that edge, bottom edge there, if possible. And we know that this is going upward by 7 mil. So hopefully the assembly will allow me to do that easily. So let's hide these two first. Go back to the assembly. This one, can I? Hide. Oh, that's fine. That's fine. That's fine. Where was I? Yes, there we go. Transform. Oh no, this goddamn thing. It's at an angle, which is not great. How do we do this? You can drop. You can try and drop it. Cancel. Save. Because what I'm gonna try now is might break stuff. What I'm saying, it might absolutely gonna break some stuff. Because I'm gonna unground this, so now this thing can move. I'm gonna transform it 1 mil at a time, so I'm gonna grab that, put it there, like so. That way we can see it jump 1 mil at a time. 1, 2, 3, 4, 5. There we go. 6 mil? Why are you dropping 6 mil? I don't understand. I don't understand. Is it worth making another assembly? I think I should do that instead of this. I mean, out of this we already got a template, right? Well, yeah. Using that we already got a template done. So if so using this assembly, I already got the template. I determine the right angle for this fan, of which I have used to create this template. And that is and which would then result in this thing here, this template here. So now if I re-import this template, I'm reasonably happy with this angle now. So if we re-import this template into another assembly with 2 more fans, that mean we can manipulate things, push things around, and not to be worried about what to call no, not assembly, so that we have more grounded and we're not going to need to be worried about the angle of this fan, how this second fan is supposed to be. Yeah, that was what I'm saying. What's gonna say? Yeah. So let me do that. So I'm gonna hide that. Gonna create a new assembly. Where is the new assembly tool? Hello. I need an assembly. Oh my god. Come on. Why can I not make an assembly? Create an assembly object. Okay. So rename that first. Oh my god, I don't want that. That's wrong word button. Wrong button. Underscore 1. There was a 0 version before. Why can I not make an assembly? Hello? Am I missing something? Or is there like a sketch or something that I need to close? Hello? Dude! Limit of 1 root assembly per, limit per, okay. Yeah, if you read at the bottom there, you cannot. Okay, I'm reading the console output at the bottom. It said create an assembly object in the current document or in a current active assembly, if any, limit of one root assembly per file. So if I want to create another assembly, I need to put this in here, right? And there we go. We get another assembly. Yeah, you cannot see it because it was hidden by the precat bug count. But yeah, it's there used to be a yes, in the bottom left corner there's a what is it, readout on what the what's a bunch for a bunch of information. Yeah, so that's what that is. Assembly 2. Let's go. Oh come on, why did I keep smashing with F1 for some reason? Anyway, assembly underscore 2. Yeah, I'm gonna add there and there. This time around we start with a template, not that one. Cancel that. Let's just try that again. I don't know what I need to do there. Yeah, we're gonna add timeout dual, and yep, 2 fan. Okay. Oh, let's find a dual template. Yeah, because it's not done. It's not done. Anyway, let me just try that. Oh, and also I closed the window. Oh, I did close the window to the live stream. So 1 sec, I need to reopen that so that I can see what's going on in the background. What the hell am I looking at? Alright, alright. Ooh. Okay. Okay. And that as well. That is not part of an assembly. This is the assembly. And oh boy, they need different color. And what the hell is this? Okay. Okay, let's just make it look, hopefully that, oh, there we go. That's the button. Doesn't make it look any better. So for some reason, it looks like ass. Whatever. Grab that one. Hit that one. Hello? That one. Hit that one. Make it mate. So. Right. That face. Hit that face. Oh wait, actually let's spin it first. Transform. Yeah, let's spin it. Oh my, why the other one's spinning too again? Oh wait, no, actually I think I understand. I think cancel. I think I understand because these two are the same item. So if I spin them with their own axis, they're going to to both be spinning. So if I try that, yep. So I spin this, but in reference to the assembly rather than to it don't like sketching axis. It's actually that's how they had to do this. Yep. And I thought of that literally just now. So yeah, that's good to know. Okay. And we are right, the 2 mil gap. You son of a bitch. Alright, we're estimating. I am not going to be trying to figure out the 2 mil difference there. So we're just gonna hopefully just hope that these two are where it's supposed to be. Alright. Oh, and it's doing that as well. God damn you. Okay. Transform. Put 1. Yeah, good enough. Right? Good enough. Cancel. Oh, I have a feeling that's gonna come back and bite me in the ass in a bit, but not a bit. Definitely not today, but it's gonna come back and bite me in the ass later. But yeah, that's for me. That's for later me to deal with. That way. That one doesn't need to go to at all. I just need to mix it. I just need this guy. We'll go backward a bit. What's the distance between that and that right now? Shoot. This thing is 97 across, right? So if I grab, let's show the part design really quick. Grab that distance. That's 100. 100 plus 9 plus 97. Remember, the box is 300 in width. No, in depth. 109 plus 97. That is 98, 100, 198. Okay, that's good enough. All right, so you say exactly where you are. Just go down a little bit. Close. By going down a little bit, I mean I can go back to assembly really quick. Grab that. Oh, and save. Always save. I grab that, make that. Oh, why are you not working? That and that. Hello? Guys? That. Recat. Work with me here. Alright, good work. Oh, it did, but not great. Well, at least I have now. I have the opportunity. But first, before we do that, let's match these two as well. Okay, save that. And then match these two. But this time it's 100 now instead of 109 or 110. All right, let's. Oh no, this wrong distance, wrong dimension, wrong direction. Oh my god. There we go. Okay. Got the second fan placed it correctly. That's simply where you got to go. And yep. The passwords. Okay, so we make a club. So I definitely don't need this anymore. I really need that. Assembly 1. And do we need that? Oh yeah, assembly 1 is for the fan, don't we? Isn't it? So alright, I'll keep that around. This sketch. This sketch is just it is for assembly 1. Scaled picture. Scaled picture, then we've got the fan. I'm just putting things in place so that I know where how things were developed. So we got the scaled picture coming in, and we'll put the sketch, and then we'll create the fan out of that, and then we'll create a master sketch which we base the assembly 1 on. And using the assembly 1, we figured out the template for the fan mount in general and the fan mount for the dual configuration. So now we've got assembly 2. That's that. Assembly 2 also is just another reference, so I'm just going to chuck that in there. And I'm going to grab the clone of that, if I can. Can I? Oh crap. Okay. I can. Yeah, I can. Just put the part design part. Where's the clone function? Do we have a clone function, that is? Come on. I know you have one. Makes my life easy. Come on. It doesn't have it. Okay. We shall then create a copy. Refine shape. Okay, we refine shape. Refine shape is not a normal copy, not a simple copy. A simple copy would not change. The reason why I am never mind. The reason why I'm stingy about making a normal copy is that if I were to change this base fan later, I have to do it via the older sketch, and it won't immediately translate to the new one because of the simple copy function that I'm about to use. So the best one, in the perfect world, I could be able to click on that and just clone it. Using linking the new piece that we're working with the old piece, but I cannot do that for whatever reason. I don't know why, but yeah, that's that, and we're just gonna have to deal with it, I suppose. Damn it. Okay. Okay, I'll deal with it. We deal with it. We will deal with it. This piece now become extremely valuable, huh? Okay. Okay, so just giving myself one last thought on how is this exactly how I want it, or do I anything else? Is there anything else I want to add or remove from it? And I couldn't think of anything right now, so let's just move on. Create a simple copy. Yep. Oh, pain of it. It's not the optimal one, I can tell you that much. Okay, okay. Alright, so and now with that one I can now clone and edit it off. Do we clone that? Not edit it. No, we cannot. Let's clone it. I now do copy that name. As oh, I just realized that time I do supposed to make a tool template. Like auto one. Yeah, that's supposed to be like that. Auto 2, you mean? Yeah. Two. The auto 2. The auto 1 is in here, but yeah, because we did that. We changed the name after the fact, so the name didn't translate. Actually, I'd rather not confuse myself in the future, so grab that. Put the name there. Paste that. Put it in 1. Like so. There we go. Oh, you guys can hear the click. Okay. Oops. So that is absolutely a reference, right? Alright, that's a reference. So ultimately, that's 3 hours length. All we have to show for it is one little piece of plastic. Nice. Okay. That's how 3D. That's how design goes sometimes. And why that clone? But no, we don't. Let's hide the assembly so that we know what the piece that we're working with. And for this piece, I want some reference point. Ooh, don't click on it. I want that in there, and I want that in there as well. All right, so that's the ref point. That's the reason why we make assembly 2. Now we're gonna draw on that surface. Yeah. Let's see if this will work out. So I'm gonna grab a random plane there, hide it, draw on it, and I don't need the rest of the sketch. So we just grab that one and that one. That's the opening. That is the edge of the output. And of course, we don't need to worry about this size, the wall of this side and the wall of this side, because that is gonna be handled by the what they call the outer wall, the outer strap that we're gonna slot this whole thing into. So I'm just gonna draw that like so. I'm gonna correct the error in a sec, but for now, let's just finish this. This one doesn't need to be horizontal. That's it. Yes, and much like the other one, there will be a gap here, 0.2, and collide. Oh no, actually, unlike the other one, actually, because this gap needs to be 0.3, because there's not 2 on each side, so we need to give it a little bit extra. 0.3. In fact, 0.3 is a little too little extra, but yeah, it's okay. It's okay. We can always go back and correct that later. And as for this wall here, that one and that one should be equivalent. And of the dimension, and how many? 6, 4, 5. Let's go with 5. Maybe a little 2. Oh yeah, no, yeah. I was thinking Wow. Wait, what's the size of this wall again? Oh god. I might have. Oh, I might have fucked myself. Oh. Oh, god damn it. Uh, hmm. 1 sec. Need to go check something. Oh my god. I may have screwed myself really quick. Because I'm. Might have screwed myself. Oh, no, 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 no. Oh, no, no. Oh, no, no. Alright. Put that back. Put that back in. Save first. This one maybe I may need to restart this sketch really quick back to this specific save in a sec. But I want just to know how thick is the wall. 3 mil. Should I make it 2, don't I? I should make it 2. Oh no, 4, sorry. Make it 4 because there's a fan mounted at this surface. Oh, why did I say? What did I say? What was my thinking at the time? That when I decided to make it 3, I said something about reinforcement. Reinforcement. Okay, actually, revert that. We don't need it to be 3. 3 is fine. 3 is fine. Yep. 3 is fine. Let's hope. Here's a hope. All right, 3 is fine. But this one will not have the same reinforcement that the other one has. So I reckon I'll make it 4. Just to make it like slightly closer to that. So we're gonna extrude that two surface together. So about that, it'll work. I don't think it will. Ah, great. Yeah. Now would you not work? Why did you broke? Through the surface? Close? Hello? Anyone? Come on. I was banging on this idea that this may work. I need to make a strout. I want to make a strout. Cancel. Okay. This one and then that surface. Can you extrude the other way around? No? Oh, shite. How we do? Damn it. To do this, I want to connect that. Basically, I was hoping that I can just like merge these two together to create just I don't know how that's supposed to work, but yeah, but I don't think it working. So now I need to figure out how to do that manually. And let me just cancel this. Get rid of that as well. So what if I make it symbol? Huh? We can make symbol. Get rid of that as well. Come on, up. Just testing. Would this work? Would this work? Okay. That surface and that sketch. And can you actually connect this? Yes, you can. That's half the battle, I suppose. The angle is a little steep there, though. Yeah, this angle of the on the funnels a bit steep. May have second thought on that, huh? Oh, and yeah, no, sorry. Right. All right. I think, yeah, that's fine. That's fine. I'm just thinking something. I'm just thinking of something that I may want this to go a bit further out, so that I don't want this such a drastic like sweep right there. So I just get okay for now to keep that that shape in place. But I'm going back to the assembly and increase that angle, the distance, which I have noted here. So give it 10 more 10 more mil, like that. And of course, because I did that, need to block that, put that again. There we go. Oh, and I need to define this, fully define this. And yep, that and dimension 3. Oh, okay, perfect. All right, so nice. Printing this is gonna be a pain in the ass, I can tell you that much. But that's once again, that's a problem for future beneath. For now, we'll just make the other one as well. So before we move on there, let's grab that one. Let's create a random plane there. Okay, draw on it like that. Hide. We don't need this. Oh, we actually do this. Let's do this here. Yeah. Okay. Okay. Grab those two to create a bit of a yeah, not that one. A little. Oh! I do need the other one. No, I don't need it, but I need this. I need that one. I'm not gonna use it for I'm not gonna reference to it, but no, I do. I will. I think. Alright, so something like that. I'm not committed to this just yet, but let's see how this goes. Okay, give it a run. We'll give it a dimension. 27 is good. 27 is good. Yep. 6 is fine too. Nothing wrong there. I don't discriminate. And grab the other random plane. That one. Yeah. Draw on it. This time I draw the other edge as well. So I shall grab. Oh wait, no, don't grab any other. Just grab that one. There we go. Yeah, that one's perfect. So I can just make that and make it equal. Okay, I make that and that. Oh, come on. That shift, no, control that equal. You gotta make me do this for real. Come on. I don't want to have to. It's too eager to set that point. So let's put that there. Make this whole number here. Make these two equal first. Then now we merge these 2 points. Like so. So now we have that, and now we create another that one of those. Yeah, just like that. Perfect. Right. You doing good? It's gonna look a little weird in the corner here. No, so. Oh no, no, it won't. It won't. Okay. Oh no, it did. It does. It does. God damn it. Maybe not a good idea. Maybe. Let's hide that away now. Maybe for that one. Maybe that top bit shouldn't be a straight one. Yeah, should be. Oh god damn it. Ugh. Come on. Seriously? That's not straight. There we go. There we go. That's good. But these two are definitely equal. I definitely want them to be equal. But this can be in line with that. Yeah. And instead of just coincidence. Oh no. I need that one actually. So that one like so. So we got a 45 degrees angle instead of whatever it was before. And it still look a bit of how to put it? Ghetto. I take it back on the first one actually. So for this one, I think I don't want that. Yes. Oh my. What did I do? Oh shit. Okay. Oh no. Uh-oh. Hello. Alright. We good. Alright, so instead of, because the reason why there was that weird intersect between the two pieces there, because I have because for the first additive lobe, I take the entirety of that surface and pull it up there. So there's a bit go diagonally to that and that point there, which is not good because that point there meant to go there for this second piece. So in other words, what I need to do is that I need to draw another just to make sure that I'm on the right one there. Okay, yep. I need to draw another one of these and take into that one. So take that one and that one. Yeah. And this second one is the one that's gonna extrude to the vertical tab. And I hope you guys cannot hear the truck running outside, but so that one and that one should go together. Oh man, I have a feeling I'm gonna cry to cry. I would be crying if I had to redo all this, or I need to edit this in the future. Gonna be a pain, true and absolute pain. But for now, and why are you doing that? Hello, come on. Okay, this one gonna stand all the way up there, and that one just go. Okay. So, that one? No, that's the other one. Yeah, that one. So that one, instead of being there, I want you to be there. And how do I do that? I'm gonna grab that point, make it center, make that and that equal, and that tangent. No, that dimension. So we got that one first. Yeah, so stick out a bit. The other one. Wait, what's the one look like on this? Oh yeah, because that one took the so I need to grab that. No, that one, that one. And instead of connect them to that edge, instead of that, I pull it down like so. And instead of this, I put this up here. Imagine. Align. Coincident. And this one horizontal. Would that work better? Yeah. Yep, that's perfect. Beautiful. All right. And now, oh my god, don't touch anything. Don't touch that. Now we just take that, extrude it so that we had some strout for this thing. Do we want to do that with this like this, or do we want to yeah, because if I grab just if I just grab that surface now and just go for it, if we were to edit these additive lock in the future, it's gonna break something, I think. So what I'm gonna do, I'm gonna grab that turbid there. It's an extra work, but yeah, better safe than sorry on these kind of thing. Just cut out everything. Any ooh, that one? No, that one? No, oh, that one, yes. And that one, yes, 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 yes. Okay, hide that and hide everything actually. Yeah, so we want that guy and come on. Okay, we hide the center point. No, okay. Okay, I'm just going because I'm gonna grab that one. Yeah, that's fine. Ah, hate it when things just overlap. Come on, come on. Nope. Oh, it's just we just need to go for it. Don't need to hope. Don't need to pray for the thing to like pop up like the tooltip icon. Okay, good to know. Good to know. Yeah, that should lock that one too. Like so. Good to know. What's that? Now we extrude it. No, we hide these two first to make it look good. And now we extrude it about 5 mil. The other way. Oh, 10 look good. That one 10 too, right? No, that one is 5. Alright, make it 5. Make it looking coherent. At least attempt to make it coherent. Alright, so that is our docking system for the dual fans. Save. It's safe, right? Oh wait, no, not yet. Right, now we save. So first, let's before we move on, let's export this really quick. I want to see it on the what do you call, on the slicer. So actually I can so just put it, make it small, and give me a moment. I'll go to that one and make it the slicer. Where's the slicer? Oh, on unit. Okay, the slicer is that one. Yep. Yeah, I want to see where it go. Where did I save it? Hello? I'm not doing whatever. So in the orientation, that is as it's one we wanted to. Okay. So hang on, support. How do the slicer see the support system? Go play now. Automatic. Oh wow. The slicer don't see the angle that need to be supported. That's new. That's good. All right, slice that. Will it mark the part that's overhang though? No, they don't. Oh my god. I am all right, let me pat myself in the back really quick. There. That is perfect. That is perfect because that gap. That's fine. It's fine. But yeah, no, this is perfect. That's good. Good to see. Okay, so let's go back to the to this one, to the cat model, because now that we had make that, we need to now figure out the mounting solution for this fan and such. But before that, I need to use the bathroom. One minute. BRB. Actually, I'm not gonna put the BRB screen on. I'm gonna put this. This is cooler, but I'm gonna meet myself. Right, I'm back. Okay, now we're going. All right, yeah, we need to figure out how to mount the thing together. So for this one, it's pretty easy. Just punch a hole through, and one thing that I'm gonna do in a bit is to add some what is it? Support, not support. Reinforcement at the back, so that it have more thing to bite on for one, for the screw to bite on for one, but also to make this a three-dimensional instead of this slim 3mm wall. Now, so you see what I mean. But for this one, not gonna lie, I wasn't paying that. I was not that much attentive on how to do this one. We can extend this edge further, right, and just so that we can just screw it in from this side. Dun, dun, dun. How would we do that? Because this face right now is pressed against a wall, a 3.3mm wall. We can mount it to the wall. How big is the countersunk on an M4? No, because the resolution I'm thinking of right now is pretty annoying. So maybe we increase that on this side. I'll take that, extrude, and then this is gonna be annoying. Okay, it's pretty tricky. This is a docking system, but we do need to add the fan. This fan hole is 4mm. We definitely don't want to add. I don't want to add M4 into any of this. I don't want to have more screw in the system, more screw types in the system. More necessary. What do we do? What do we do? And the reason why I'm hesitant on to doing what I said earlier, well, my previous plan, is because this thing is technically an overhang on its own, right? Like that, going up at an angle. So if we were to create some heavy bit over here on top, this is basically at the top of a print. This is the last what 2/5 of our print. So it will have a massive lump of plastic up here, it's going to be very hard for the bottom wall here to actually hold that in place. So I'm thinking, what I'm thinking right now is maybe we have a separate piece to allow this thing to mount to the base directly, and then we just drop this thing in place. But if that's the case, if that's the case, oh, if that's the case, this should be the single fan configuration config. Yeah, let's do that. This shall be the single fan config, right? And what? And then we can make another funnel that basically where that as if this one does not exist, and just like a straight from that to that kind of funnel, and that's a single fan. And this, if we set this as single fan, in that, and then we can start creating the shell around this whole assembly now, and we can put the mounting point on that one for this fan. So yeah, actually I'll go with that. So with that in mind, I'm just gonna ignore the mounting of this fan now. I am going to sort out the mounting on this fan. So to do that, I need to hide this first. I need to grab making sure. Okay, let's hide this additive block really quick. All right, so I'm gonna add a random plane there. Okay, and I'm gonna draw on it. First thing first, grab the holes. Oop, not the end point of the hole of pin, the holes. Like so. And we're now gonna create a pattern. Oh, and we wanna grab also. Oh no, we don't want to clone, we want this. Yeah, we want that surface. There, like so. Okay. Okay. We get rid of that. I can see my the selection. Not even this, not right either, but alright, better than nothing. Alright. Okay, no. Oh. Oh no, don't go in the center. Just do that. Yeah, just do that. Right, so that, collide with that. Collide with that, yep. These two are construction line, and they are equal. Yep. And of course, we need to close the sketch so that the line is not as close. Like so. And why are you jumping in the bizarre? Alright. Wish someone know FreeCAD can come join me and show me how to lower the sensitivity of that midpoint selection there. I know it's possible, I just don't know how to do it. Obviously, I don't think there's many people watching. So that's okay. That's okay. We work with what we have. Right there. Right there. That one. They are equal. Oh, wait. Why are they? Wait. Why? Wait. When I say they equal, I don't mean. Alright, so that makes more sense. Alright. I don't know why that the other one was suddenly get defined, but this is what we want. We want this leg to be dimension. Oh, not radius. Come on. Mode. 8. Give it an 8. There's no real reason for this. It's just I'm just doing this because I can. But do we want to do that? I'm thinking. Maybe not. That I do 1/8. That and that I do 1/8, but I don't think the end of the leg need to be 8. And yeah, let's not make those 8. Okay, so I put that 5 away, and I put the 11 away. Yep, that way. So in this, I need to draw a construction line between that point and that point, and that is the thing that's gonna keep everything horizontal. Same go down, same with this one. Like so. This one can go down. So these two can be equal, and they are equal to dimension 8. Oh, not that. Dimension mode 8. Yeah, okay. So that's that. Right. But these can shrink a little. Make it make it 4. Yeah, 4 sound good. There's no real reason one way or another, but why you? Ah, what's that? Okay, this is strange. Why are you get rid of that? Oh, right, because the tension's no longer okay. So it's not gonna be the connection between those two is not at the tip anymore. So I need to get rid of that. So I can move this backward and collide that with that. Coincidence, not collide. And now a second thought. Point 2.4. That is the number 2.4. That's 6 wall, right? That's 6 wall of a 2.4 nozzle, 0.4 nozzle running around. So if I add another 2.8 is 2.8 would be 7 wall. 3.2 is 3.2 is not 8, it's 8 walls. I don't think I need to go all the way up there, so let's just do this for now. And I extrude this up to face, and I extrude this that touch the up to face, sorry, to face. Yeah, like that. So then touch the wall of the what it called, of the base. It's looking good, I think. Yeah, I might be biased. I think I don't want that to be 2.8. It's still too big. 1.6. So 4 wall in total. 4 of these walls is in total. Like so. And do we want it 8 mil on top? Oh. If it's lagging, even anyone can tell me, because yeah, the stream is screaming at me and saying it is not doing well. And I can see, oh god, frame drop. Alright, let's hope this is good, because I have no way to do that for sure. Oop. Alright. It's ignored. I'm sure if it's bad, then it is bad. I cannot fix it. No, because the hole itself is for an M3. Right. The hole itself for an M3. I think it's an M4, but anyway, we're doing an M3. I swear to God. One sec. We'll open the stream on my other device here to check what's going on with the warning it's thrown at me. Okay. Okay. I hope it's working. Anyway, this is M3, so 3 mm in diameter. 7 minus 3 is 4, so the wall is going to be 2 mil. All right, I take it back. That's fine. Yeah, should be. So that is the leg. Now grab that random plane again to create another sketch here. Oh, and cross that really quick because I want this one. I do need it to go straight. Close to 4. Yeah, I can tell the stream a little drippy. So, yeah. Apologize if you guys actually want to hear it. I hope the what is it called? Caption, the auto caption button works still. 3 or 2.8, 2.9, 2.9, 2. Oh no, not 29, 2.9. It would be funny to see if that one turned out to be a 0.4. Reverse. And go down by, well, we're going to use M3 by we're going to use M3 by M335. M335 for the bottom one, and 340 for the top one. 335. Okay, let's go for the M3 by 40. Not standard, because that one's going to be important. Yeah, M3 by 40. 40 minus 33 is 7. So we go down 8. 8 mil. Yep. That one is 30. That one is a little worrisome. Hopefully we had enough space there to no, it's okay, it's fine. Because I was worried that's not enough like material here for thing to bite onto, but it's 2 mil, right? At least 2 mil, so it's fine. 2 mil plus 3. 2 mil plus the 3 here. So we got 5 mil of the depth for the screw to bite on. And for any excess what do you call screw length, if there is excess screw length, we can always just add a washer or two on this side, which we might have to do anyway, because this hole, if the picture is correct, is made for an M4, which I don't have and don't want to use. So that's that. Close. The back of this is a little bit weird. It's feel weird to have this thing how is it, empty like that. Or maybe I just make it through all. Should I make it through all? It'll look weird if I make it through all. Yeah, no, just keep it like this. It's fine. It is fine. We don't even have the fan in hand, so we can't even test this. So, with that said, how long have I been streaming? 4 hours and 20 minutes. Oh god. What time is it? It's 6:20 here in the UK, and I think I need to stop it there. We can continue this tomorrow. Tomorrow, as from the look of it, it seems like the work for tomorrow is to create a shell so that we can then now visualize how everything is slot put in place. Obviously, as I mentioned above as well. The other thing that I need to create now is a single fan duct so that we can duct this to that surface there. Hello, Atlantis work. You here literally at the end. I'm literally just summarizing the thing I'm doing right now. Anyway, yeah, I need work for tomorrow, basically. Work for tomorrow. This duct here is the dual fan duct that will need to be tested and all of that jazz. But anyway, we'll do that when we have the fan in for testing. Oh, one sec. One other thing that I just noticed, I need to trim this off by that one there, so I need to trim it right there. Okay, yeah, no, that's not the model, but good. Yeah, so this is the active chamber temperature management. This is a duct for two 9733 fan, blower fan to be pulling air out of in and around the system, from the system and anywhere from wherever we go. Tomorrow I will fix up this one for one. For two, I need to I'll need to create the base. So that is the thing that this this 3-piece system here need to slot into place. That should be it. And of course, there's a lot of work still need to be done. Obviously, you need the filter, the funnel to funnel that one to towards the exit in the single fan configuration for those who want to use that instead of this. We'll need what is it? The rest, the basket, the carbon basket on top, and the HEPA filter basket on top of that. And then we also need a output hatch thingy. I have the mechanism on that is still what's one of the things that I want to do. I don't know if I can accomplish it. Is to have a machine that can automatically open and close the change the airflow from these fans in exhaust mode, for example, to blow the hot air out of the system, while in circulation mode pump the hot air back in. And I have a rough idea how to do that, but I don't know how to do that. We'll figure it out, hopefully. And yeah, look forward to it. We got plenty of streams to go for, and honestly, this system here should be a optional thing anyway. So if I fail, then I fail. Don't worry about it. I did myself. I'm just talking to myself. Yeah. All right. Anyway, I'm tired. All right. Thank you for you guys for watching, and yeah, catch you tomorrow. Cheers.